Great people, welcome to NameTech channel. My name is Nehemiah, and guys, I'm very happy to have you on board. So today we are going to learn Numpy, and Numpy is a Python module, especially for those taking data science and machine learning. It's a very fundamental module for those fields, data science and machine learning. But guys, we are going to begin from the very basics to the advanced of Numpy. But guys, before I begin, please take a minute to subscribe, like and share the video to your friends. And to the returning subscribers, I really appreciate you very much for your continuous support. So first of all, let's understand what is Numpy. As I said, in Python, basically guys, in Python we have a list, so you can use a Python list to serve as the arrays. However, Python has a library used for working with arrays, strictly for arrays, and that is Numpy. So Numpy stands for numerical Python, and it is also a function for working with basically in domain of linear algebra, Fourier transform, and matrices. But why should we use a Numpy instead of Python list? So guys, basically guys, in Python we talked about the list, which serve the purpose of array. Remember we talked about Python. If you have been following this series, we had a profound course on Python, and we talked about the Python list. So basically they serve the same purpose, but remember Python lists, they are very slow. So Numpy aims to provide an array object that is up to 50 times faster than the traditional Python list. So the array object in Numpy is called ndarray, and it provides a lot of supporting functions that make working with ndarray very easy. So array are very frequently used in data science, and where speed and resources are very important. So remember, data science is just a branch of computer science where we study how to store, how to analyze, and basically data, and also basically to analyze data for deriving information from it. So if you are learning data science, and then Numpy is for you, you have to learn it first if you want to know how to deal with the arrays. But why is Numpy faster than the list? So guys, basically Numpy arrays basically Numpy arrays are stored at a continuous place in memory, unlike list, so the processes can can access and manipulate them very efficiently. So this behavior is called locality of reference in computer science. So guys, basically this is the main reason as to why Numpy is faster than the list, and also it is optimized to work with the latest CPU architectures. So remember Python Numpy is partially written in Python, but most of it require first computation. Basically the parts of which requires first computation are written in C and C++. Remember, these are first programming languages. They are very efficient. However, for this course we are going to focus on Numpy, but strictly working with Python. So you can always find the reference to or the code base for Numpy on GitHub, and Numpy. Let me just show you. You can just search for this is first of all hypertext HTTPS hypertext transfer protocol has a secure extension, and then it is github.com and then Numpy, and then Numpy. So when you navigate to this site, you are going to find the reference to the Numpy. You're going to find everything about Numpy here. However, because I'm teaching, let us focus on the video. And so first of all, how do we set up the environment for writing our codes, for working with Numpy? So first of all, before you're working with Numpy, you must have the Numpy module installed in your system. So guys, basically you can decide to use two ways. You can install the Numpy module, externally, or you can use Anaconda. Remember, Anaconda is a very powerful, environment which usually come with all these Python packages for data science and machine learning. So you'll not have to install the external modules. However, let me show you how you can install Numpy. So guys, I think by now you have installed Python in your Steam system. If you have not installed Python, ensure that you go to the Python website, python.org, python.org, and then what you do, just download for your operating system. Mine is Windows, but remember, for me I already have it, but just click on it, and then ensure that you click on all check boxes so that you may install the required packages for Python. Ensure that you click on all check boxes. So it will come with a package manager called PIP, which PIP can be used to install other Python packages. So once you have it, just open your terminal. Once you have installed first of all Python, then go to your terminal. You can use a command prompt. You can use a shell, PowerShell. You can use any command line. You can use even Conda, or on your Linux terminal. Any terminal, guys, you can just use it, and then just type here pip install Numpy, install pip install Numpy. So it's gonna install. Remember, for me I already have it, so it won't install it because it is already, unless it's an update. So how do you check the version of Numpy that you're using? First of all, guys, let me show you an alternative way on how you can work with Numpy. So we have an environment for data science and Python environments, which is called Anaconda. Anaconda usually come with all Python packages like SciPy, Numpy, Matplotlib, and many other and Python. So you'll not have to install these stuffs externally with the PIP. It usually come with them. So just go to the website anaconda.com/products/distribution. Then I hit enter, and then while you're in this page, you can download for your operating system. Mine is Windows, that's why it has brought these options here, option to download for Windows. However, download for your operating system. And then once you have installed, basically, as you can see, let's check this description here. Everything you need to get started in data science on your workstation, free distribution installed, thousands of most fundamental data science, artificial intelligence, and machine learning packages. You can see that's all the packages, manage packages and environments from desktop application, deploy across hardware and software platforms. So Anaconda is such a very, very powerful tool. You can use it. So once you have downloaded and you have installed, you can launch anaconda.navigator. And if you want to follow along in this tutorial, you might want to use Jupyter. I'm using Jupyter Notebook to teach. So just click on it, click on the launch, and then once you launch your notebook, Jupyter Notebook, then it's gonna open in your default browser. My default browser in this case is Google Chrome. So I'm gonna decide where I'm gonna place the project. So I'm gonna place here the desktop. And then and you can click on the new, and then we are using Python 3. This is the latest Python interpreter that we're using at the moment, at the time I'm recording this video. So click on the Python 3, and then what you do at this juncture, as we wait for it to load, here at the top you might want to change the untitled title to your preferred title. Perhaps let me say Numpy full course, or you can give it any. Perhaps let me try to minimize these tabs so that it might not confuse you. So let me just close so that we may have only these two tabs here. So guys, basically we have installed the Numpy in our system, and we have the notebook. Basically guys, you can use any other notebook, but it's a good practice to use. If you want to follow along, just use Jupyter Notebook, but you can use as well Visual Studio Code. You can use the IDE like PyCharm. You can use any other notebook like Sublime Text. You can use Brackets. You can use any text editor, Notepad, plus plus, and many others. And so how do we import a NumPy to be used to if you want to work with a NumPy? Now you have installed in your system now, but how do we import it from the system? To import it, we use the import keyword. Remember in small. Remember I told you while we were discussing Python that Python is case sensitive. When you just misspell or use capital, when you just use import in capital is different from import in small, in lowercase import. They are two different things, so ensure that you write import in small letter, then a NumPy itself. So basically this is how you can import NumPy from your system, but it will only work if you have installed a NumPy in your system. So this is how you can install it, but how can we use it? So to use it, perhaps let's create an array. Sample array. We're going to talk about this stuff in much details, but in a second, let me show you. Let's create an array, a variable called array. Then let's assign it to this numpy dot array. And then in this array, I'm going to pass in an array list of perhaps 1, 2, 3, 4, 5, and so forth. So here we can print out, let's say print that array. Guys, it's a good practice to use descriptive names to describe a variable. Is a good practice to use descriptive names to define a variable, because for example, if you are collaborating with other peoples, and then your variable, you give it a funny name like x, a, b, c, d, and such stuff. So it's not a good practice if you are experienced developer. But in this tutorial, perhaps I might use those short names for the sake of time or such thing. But as a developer, it's a good practice to use descriptive names. You can use camel case, you can use a snake case, or the other one you can use. The other one is what it is camel case. We have snake case, and then we have the other one. I think I've forgotten, but ensure that you're using the descriptive names to define your variables. Like in this case, I've just used array to define that this one is a NumPy array. So to print out, we can run it, and then again you can see we have the output. But again, most of the time we'll be using NumPy as an alias. Remember, an alias is just like the other name of something. Like for example, if I say my name is Nehemiah Wekesa, but the alias for Nehemiah Wekesa can be Nametech. So Nametech will stand for Nehemiah Wekesa. So it's just like a nickname for something. Like for example, if I want to use this NumPy as an alias, I'll say import NumPy. But in that case, you have to add in this keyword as keyword. Import NumPy as np alias. So once I do that, and then let me just copy these codes, and then I paste it here, and let me paste it there. So when I use here np, remember I forgot these tabs. It should be removed. This way, guys, it will work. Remember, np is a default, is kind of a default alias for NumPy, but you can use even n. Then once you have changed there, you have to change it here also. You can use anything, but default one, and the best practice to use np is a default one for in the NumPy documentation. I think np is a default one. So let's use np in this tutorial. So this is how you can use NumPy as an alias. But guys, I want us to check how to check the version of this NumPy that you're using. How do we check the version? So first of all, let's import. I don't have to retype it again. Let me just copy, and then let me paste it here, and then here let's say print, and then we're gonna pass in this np, the last, and then dash underscore, then let's type in version, and then closing two underscores. So when we run, we'll get the version of Numpy that we're using. You can see it is 1.23.5. so basically this is how you can check the version of Numpy that you're using. Now let's talk about on how we can create the arrays. So Numpy is used to work with the arrays, as I told you earlier, and the array object in Numpy is called ndarray. And so we can create a Numpy array object by using the array function. Let me show you that I think, but already I've showed you here. You can see it is here already. Do I have to print it to retype? Let me just do that so that you may understand. So first of all, I said we use the import keyword to import the module, and that the module itself is a Numpy, but as an alias np, and then we can create the variable for our object array. Let me call it array, then assign it to this np array, Numpy array dot array. I see that we use the array function. If we want to create a Numpy ndarray object, we use the array function, and then remember function must be inside this opening and closing parentheses to define that this one is a function, or you're calling a function. And then now we want to pass in the Numpy arrays here, so we can use the list. Perhaps let's say 1, 2, 3, 4, 5, 6, and so forth. And then now here the print function, we can say print. Let's say print, and then let's print first of all the array, and then the other thing I want us to check out if it is ndarray object or not. Remember I said that we create the Numpy ndarray by using the array function. So I want us to check the output if it's truly the ndarray object. So in that case, guys, let's say print again, print, and then we want to print type, and the type of the object here, and then array. So what we do, let's run, and then guys, basically you can see it has printed out what these are lists, and then you can see the type here of the object is ndarray. So guys, basically this is how you can create the ndarray object. Remember this type here is a built-in Python function which tells us the type of the object passed to it. Like in this case above, it shows that this array is a Numpy .ndarray type. So to create an ndarray, we can pass a list, tuple, or any array like object into the array method, and it will be converted to an ndarray. Like in this case, we use the normal list, but you can also use the tuples. You can also use anything, any data type here. But I think let me talk about something very important in Numpy called dimensions. You've seen some people talking about the 2-dimensional array, 3-dimensional array, 1-dimensional array, and so forth. So let's talk about dimensions in arrays. So a dimension is basically in arrays one level of array depth, or a nested arrays. So talking about the nested arrays, a nested array, basically these are arrays that have arrays as their elements. It is an array, but each element inside is another array, as their elements. I don't know if you have understood, but let me show you guys an example here. For example, a 0-dimensional array. For a 0-dimensional array, first of all, let's import the module as np alias, and then let's create a variable called array, and then let me assign it to np dot array, And then I can give for zero-dimensional array, you just pass in anything. Like for example, you can pass in a string, an integer, like let's say for example something like a 50. So basically this one is a zero-dimensional array. Remember I said that nested array, these are arrays that contain other arrays as their elements. Like for example, this one doesn't have any other array inside it, so this one we can call it a zero-dimensional array. So what I do, let me try to print out. You're printing out array, so it will return 50. It will return what? It will return 50. So guys, basically there's an error here, no module named Numpy. So I think there's an error here. Yeah, sure guys, you can see it is Numpy. So there's an error, so you should be keen when coding. Now for one-dimensional array, guys, here instead of 50, an array, remember, can be a list. Is defined using this something like the squared brackets. So example for one-dimensional array, remember the above was just as a zero-dimensional array. So for one-dimensional array is an array that contain the array element, a single array element, basically other array as their elements. So in this case, perhaps for one-dimensional array it can be, for example, 1, 2, 3, 4, or any value inside this list. So and this shows that this one is a one-dimensional array. You can see we have only array in that array thing. Now for a two-dimensional array, is an array that has one-dimensional arrays as its element. Basically that's a two-dimensional array, an array that has one-dimensional array as its element. You can have several one-dimensional array, but let me show you that. So this is our array element, but inside it we have another array element, one-dimensional array, 2, for let's say 4. So basically this one is a two-dimensional array. Is an array that has one-dimensional array. Remember this one is a one-dimensional array, but now this one is an array. For two-dimensional arrays is an array that has one-dimensional array as its element. And so when you run, this one is a two-dimensional array. Remember you can have several, like you can add even another one-dimensional array, like 6, 7, 8, 9, and so forth. So still this one is a two-dimensional array, but it has two one-dimensional array as its element. So for three-dimensional array, guys, it's the same thing. This one is an array that has two-dimensional array matrices as its element. So like for example, three-dimensional array is what? Is an array that has two-dimensional array as its element. So basically these are three-dimensional array. So it is this empty, basically this what opening and closing, a pair of opening and a closing square brackets, but inside it has Alright guys, how do I explain this? Let me show you. So basically guys, we know that this one defines an array or a list. So this one is, these empty brackets define that this one is an array list. But now inside it, for a three-dimensional array, it has two-dimensional array as its element. And we know that a two-dimensional array has this pair of square brackets. And inside the two-dimensional array, we can have a one-dimensional array that has some values like any value. So basically this one is an example for two-dimensional array. It's an array that has two-dimensional arrays as its element. Like I can have even several two-dimensional array, comma, and so forth. You can have several, and then when you run, you can see we have the same results. For 4-dimensional array, just in that series. Now, how do we check the number of dimensions? Now, Numpy arrays provides an ndim attribute that returns the integer that tells us how many dimensions the array has. Like for example, guys, let's check out the number of dimensions that this one has. So we all know that it is a 3-dimensional array, but how do we check? You will say, you first of all pass in your object or a variable, which is array, but then you use this attribute called ndim like this. Then when you run, you can see it returns 3. So it means that this array of ours has 3-dimensional arrays. So you can try with other dimensions. And then again, remember, an array can have any number of dimensions. Like in this case, I've just showed you to 3-dimensional array, but you can have several. You can have 4, 5, 6 to infinity number of dimensions. So guys, basically when the array is created, you can also define the number of dimensions by using the ndim argument. Like let's create our dimension. So this is our array. This is our array, and I said that an array is defined using this. Should be the angle opening and closing of the angle brackets. And then inside the 8, let's create something. Let's add in some elements like 1, 2, 3, 4, 5. 5. And then now, guys, basically if we want to obtain or to return a certain number of dimension, we can add in this argument called ndim. So just say ndim, and then I specify the number of dimensions that you want to return. For example, if it's 6, and then here we can print out the array, the object itself, and then we can also choose to print out something else, like let's say print, and then let me add in a string, like let's say the number of dimension. Is this a spelling for dimension? No, dimension. The number of dimensions are or is white space, and then let's add in this argument here so that it may return what? So that it may return what? The number of dimensions. So let's say it was what? First of all, it is array. First of all, we separate an argument with a comma, array, and then a dot. Remember that object, that attribute to return the number of dimension, it is ndim. Remember, this is different from this one. This one is ndim. This one is used to create the dimensions, and this one returns the number of dimensions created. So you should be keen so that you may not be confused. And then what I do, let me run, and then I can see the number of dimensions are 6. Alright, 6, and then I can see it has created this 6-dimensional array. So remember, 6-dimensional array is an array that has 5-dimensional array as its element. So I think, guys, you have gained something up to that point. So let's talk about array indexing, how to access the array elements. So basically, guys, remember, array indexing is the same as accessing any basically an array element. You can access an array element by referring to its index number. But something that you need to know, that in Numpy, indexing starts with 0, meaning that the first element has a 0 index, and that the second one has 1 index, and so forth. Like 1 is like 2, 0 is like 1, 1 is like 2, in that order. Like let me show you guys an example. First of all, let's import our module with the import keyword, and then a Numpy module, but as an alias np, and then here we are going to say what? Let's create our variable, array, and then let me assign it to the numpy array, numpy dot array. This is a function, and then here we're gonna pass in what let me pass in an array list here, like for example 1 2 3 5 6 7 so forth. So guys, basically how do we target the number of index that we want to return? Let me show you that. Let me say print first of all we are printing the array, but we don't want to return all the array list. We want to return a specific number of the index, or basically a specific index that we want to return. Like if you want to return 1, so we should do what we should pass we should pass 0. So 0 it will return 1. So when I run, remember this one can be anything, like I can even say 200, but as index 1. So when I run, it will return what 200. So the 0 is like the first index, then 1 is the second index, and so forth. Let's try 1. It will be this 2. It will be 2. And I remember it can be any value, like even that 5. You can see it runs. It returns that 5. So basically indexing begins from 0, 1. Yeah, but 1 is 2, 2 is 3, and so forth. So basically even for two-dimensional array you can access them. So for example, let me do this. Let me remember we said that two-dimensional arrays is a dimension that has one dimensional array as its element. Like you can say this one defines that this one is an array, but in this array we have an one-dimensional array inside it. So this one is a two-dimensional array. You can have several elements, one-dimensional array inside this two-dimensional array, like this way. Then perhaps let's say 4 5 6 and so forth. So guys, basically in this case perhaps let me add in some descriptive items here, like here let me say what, let me just say let me use a string here perhaps, and then let me say for example let me say the second element on the second row is so guys, basically in that case we'll say first of all we separate an argument with a comma. So the second element on the second row is, then array define the object itself, and then here so the second element is, you use 1. So 1 it will be like 2, and then the second row is, you say 1. So it will return what? It will return number 5. Let's try to check it out and see if it will return. You can see the second element of the second row is 5. So this is the second element, but at the second and then at the second basically this one is the second element on the second row. This is the second row, and then the second element is 5. So this is how you can obtain that. Even for three-dimensional array you can try with that. You can also do the negative indexing. You can also do the negative indexing, but in that case guys, you have to specify the negative. So for example, if I want to obtain from the negative side, you just add in the negative, then it will do the counters, it will do the opposite thing. So like in that case, for example, when I run, you can see it returns from the other side. That's why it is 6. So guys, basically this is how you can do that. But let's talk about something else at this juncture. Let's talk about array slicing. So let's talk about array slicing. And slicing in Python means taking elements from one given index to another given index. Like we pass a slice instead of the index from for example, from the start, you want to split some elements, perhaps from index something to index something, so it returns only the index in that frame, timeline, time frame, or that range. So let me show you guys an example for you to understand what I mean here. So first of all, we import the module. Don't forget to import the module is Numpy. Remember, with the Jupyter Notebook, you can just import the module here at the top, and then I use it on other cells. However, good practice, because I'm teaching, I want you to understand how to use this module. You'll have to ensure that you have imported the module so that you may be on the safer side. That's why I'm showing everything. I'm repeating myself all the time. But in that case, let me say is np alias, and then here let's do it. Let's create an array element. Let me call it just an array. Then np dot array. Then in this array list, I'm gonna pass in 1, 2, 3, 4, 5, 6, 7, 8, or to any other number. And then now guys, basically to slice, for example, let's say print. First of all, we define the array that we want to slice, which is the array, this object, array object. The variable used was array, and then now we specify how we slice it. We want to slice it. For example, we can choose to slice from index 1. Remember, 1 is like 2, and then a 2 index, something like for example 5. Let's run. And then you can see it has begin from remember I said that 1 is like a 2. Basically does not include the start index, but I exclude the end index. You can see it exclude the end index. So it should have brought 6, but it has reached from from 5. It has reached from 5, so it is in that range. So basically guys, that's how you can slice. And basically, if you want to slice, for example, slice element from a certain index to the end, for example, if you want to slice from index 2 to the end, you will have to use, say, for example, 2. So this one will begin from 3 to the end. Let me run, and then you can see it begins from 3 to the end. Also, you can do the other way around, from the other side to, for example, if you want to return from, you'll have to use from the other side. For example, if you want to index, for example, index 5 from the other side, so it will begin from index 4 to the other side. Like basically it returns from it includes even the I remember 5 is like 6, so it begins from 5 downwards, the other side. So that's how you can do the slicing. Negative slicing, it just specified the negative, it will be the opposite. And guys, I think you've understood that. So let me talk about another thing yet in this Numpy called data types. So data types in Python, by default, Python has these data types. It has strings, and the strings are used to represent text data, like the text given under quotes, can be single or double quotes. Those are strings. We can even write some integers, but provided it is inside the string or quotations, it will be what? It will be, it will be a string. Then also another data type in Python, another default data type in Python is an integer, and an integer is used to represent integer number or the whole number. It can be negative or positive, but provided it's it's a whole number. And then we also have the float, and the float represent the real numbers, and the number that can have decimals, like 1.2, 10.0, and so forth, or 100.02, whatever. And then a boolean type is used to represent the true or false values. And then we also have the complex. This one is a default data type which is used to represent a complex number, like for example a number that has some combination of other stuffs, like for example 1.1 plus 2.0 yj and so forth. But in Numpy guys, should I write here? Numpy has some extra data types, and I refer to data type with the one character, like for example I for integer, j for unassigned integer and so forth. So like let me just type in here for you so that you understand. So I is integer basically in Numpy, and then b for boolean in Numpy, and then u is for unsigned unsigned integer, and then f, this one is for floating number, and then c, that's for complex float. Complex float, I'm going to show you how it is used in a few, but let me just type it here for you. And then for m, this is time delta, and then m, capital M. Now small m is time delta, but capital M, this one shows this one is a data type for date time. And then for O, capital O, this one defines an object. This one defines an object, and then capital S defines what? A string. And defines a string, and then U, capital U, defines what? Unicode string. String. And then v, this one defines a fixed chunk of memory for other types, or I can just say void. Let's just say void. So basically these are extra data types in Numpy. So how do we check the data type of an array? So guys, basically to check the data type, like let me just do this. Let me copy these stuffs because I don't want to repeat. I think by now you know how to create these codes up to that point. So what I do, guys, let me make these ones comment. Let me make this one a comment. Remember, to make it a comment, you can just click on control, then at the / it will make these stars a comment. But then here, let me paste it here. And then here, guys, basically to check the data type, we have to add in another argument here, another object, another method. Let's say array, then dot, this ID type, this ID type, basically object. And then here, guys, basically let's try to run. And then you can see this one is what? This one is an integer. And then for string, a string, I said, is anything that has quotes inside it. Like if you add the quotes inside these stuffs, it will be what? It will be it will be a string. You can see this one is a Unicode string. And then also you can use other values, like let's say for example something like sharing, banana, apple. And then when you run, you can see it is also a Unicode string. So guys, basically that's how you can check the data type. But how do we, guys, basically how can we use the array function to create arrays? So like basically this function can take an optional argument called basically an option, the data type that allow us to define the expected data type of the array. But remember, it doesn't work in all cases. Like for example, you can have an integer. Let's try to say 1, 2, 3, 4, 5, 6. We all know that this one is an integer. Even if you run, it will be an integer. But now If you want to create a string from this integer, you will have to add in this argument. First of all, separate a comma, an argument with a comma, and then here you say dtype, and then what you do, let's define the type that we want to return. Let's convert it to a string. So when we run, it will be, you can see it is now a string. We all know that it's an integer, but we have converted it to, to a string. Remember for I, and then also for for u, small u, for small Unicode integer, and then a float number, and then a string, and then the Unicode strings, we can define the you can also define the size. You can define the size. You can see, yeah, you can define the size. But now for the rest, that one you can't. But remember, guys, you can't convert some other stuffs. Like for example, you can convert. For example, this one is a mixture. For example, let me say A, then a 1, 2, 3. You can't convert these stuffs to. This one can work, right? We can see it brings an error still. A is not defined, so you can't convert this one to a string. So ensure that you convert only the ones which are convertible. Others will get the value error. Like for example, in Python, value error is raised when the type of passed argument is to a function is basically unexpected or incorrect. So like for example, let's try, guys, for example, to convert a value which cannot be converted. Like let me try another case, another scenario here. Like let me say for example, let me convert a string to an integer. For example, let me say A, but A is a string, and then 2, and then 3. So guys, basically this one, if you want to convert it to an integer, we'll get an error. Why? We'll get the value error. You can see the value error because invalid literals for these stuffs here. So but let's try to remove this one. It is convertible, but if you add in a string here, it won't be converted. You'll get the error. So guys, I think you've understood that. Let me talk about the array copy versus the view. So guys, basically the difference between copy and the view, basically the main difference between the copy and the view of an array is that the copy is a new array. Copy is a new array, and the view is just a view of the original array. Basically, the copy owns the data, and any changes made to the copy will not affect the original array, and any changes made to the original array will not affect the copy. But for views, I'm going to show you an example, guys, just in a few. But the view, guys, does not own the data, just a replica of the original. But remember, this one will affect the original. If you make changes to the original array, it affects also the view. Or when you make changes to the view, it affects the original. Let's begin with the copy so that you may see what I'm talking about, you may understand. First of all, you import the code library or the module, which is Numpy, but there is an alias np. You can use any other alias name. And then let's create our array object with array variable, and then np. Remember, you can use any other name to define your object, but here let's say np.array, and then here we're gonna pass in our array list, like 1, 2, 3. Should be comma, right? 1, 2, 3, 4. So guys, let's create our copy. Let me use a variable, so like let me just say x. You can use, remember I told you that's not a good practice to use these these tabs. You have to use a descriptive name so that your code may be precise, but for because I'm teaching this, I want to make it quicker. So let me say array dot copy sorry, this one is a copy method. And then now guys, I basically want to modify the copy. I want to modify basically the original, so I say array, and then here I want to modify, for example, I want to modify the original part. So let me change the at index 1, basically index 0 targeting 1. So this one, if I modify it to some other values like let's say 100, so this one won't affect what the copy. So like let's say print the array. Also let's print what? Let's print x. So let me run, and then again, as you can see, it only affects the original, because we've modified the original. It doesn't affect what? The copy. Basically the copy, it affects only the original. But for views, let me change the view. Let me say view. Now guys, basically for view, you will find out that this 100 will be basically on these other sides, on the top and at the bottom. It will be on both arrays. Like when I run, you can see both arrays are affected. So guys, basically this is the major difference between the views. Remember the changes. Also, the changes made to the view affects what? Affects the original. Like for example, guys, let's do this. Should I here, let me say what? Let me now modify these x. Let me modify these the view. For example, let me say x. Remember the view, we used the x variable to define the view. And then here I want to modify, for example, the second element. We'll use 1. For example, if I modify to some other values, like let's say 60 or any value, guys, you'll see that both arrays will be affected. But if it were to a copy, it won't affect. You can see it only affects the modified element copy. This one we have modified actually the copy. It only affects the copy, but it doesn't affect the view. So guys, basically the major difference, and I think you've understood that. Now let me talk about the array shape. So guys, basically the shape of an array is the number of elements in each dimension. And guys, basically NumPy array have an attribute called shape that returns a tuple with each index having the number of corresponding elements. Like guys, for example, let me have here two-dimensional array. Should I use a new cell for you to understand? Let me do that. Let me say import NumPy is np alias. Then let's create our variable. You can use any other variable name to create your object. Then let me say np.array. Remember, this array function must be used. You can't change. This one is if you want to work with the NumPy arrays, you have to use this function, array function here. And then remember, this one defines a module, but at the module we have used it as an alias. And then this one is a function. Inside this a module. I mean, inside this NumPy is like a module, but inside the module we have the function called arrays, which works with the arrays. So in that array, I can add in a two-dimensional array. Remember, a two-dimensional array, I said, is an array that has one-dimensional array as its element. Like I can have 1, 2, 3, 4, 5. Remember, you can have several one-dimensional array inside the two-dimensional array. Also, let me just add in a comma to separate an element. Then, for example, let me say 6, 7, 8, 9, 10. And then now, guys, basically to obtain the shape, guys, I can say what? I can say, let me say print. Let me say a print, and then let's say array dot dot shape. basically that shape. Guys, basically in this case, we want to print the shape of this two-dimensional array. So guys, I think everything is okay. Let me run, and then you can see the shape here is a two-dimensional array, but in each array element you have 5 elements, you know, in each one-dimensional array. Basically it's a two-dimensional array, but in each array we have 5 elements, like you can see 1 2 3 4 5. So guys, basically this is how you can get the shape. Guys, basically also you can also create your own shape with the NDMIN. Like let's just have here a one-dimensional array like this, and then a pass. Let me add in some values 1 2 3 4 5 6 7, so forth. So let's create our own shape, another shape, like let's use NDMIN. Remember, this one is used to create the shape, the number of dimensions. Like for example, let's use 5. So here we'll say let me add in another print function here. Let's say print. First of all, let's print what our array object, and then here let me add in some strings, or to be kind of descriptive, like let me say shape of the array is let me add in some white space, then I separate this string or an argument with a comma, and then array, and then a shape. So what I do, let me run. You can see this is the shape of this array. You know, you can see it as returned. So guys, basically this is how you can do that. But I guess in a few, guys, what does the shape tuple represent? So guys, basically indexes at every index tells about the number of elements to the corresponding dimension as. So like in this case, these, you know, basically in this case, guys, basically each integer here to represent what it represents the corresponding dimension that it has. So I think, guys, you've noted that. But let me talk about the other thing here. Let me talk about reshaping now. We've talked about on how you can create a shape, but let me talk about reshaping arrays. So reshaping means changing the shape of something, of an array, but in this case, in this context, we are targeting arrays. So the shape of an array is the number of elements in each dimension. So reshaping, by reshaping, you can add or remove dimension or change the number of dimension in each element. Like let me quickly show you an example here, how to reshape, for example, from one-dimensional to a two-dimensional array. So first of all, guys, when working with Numpy arrays, you have to import the module itself. Numpy is an alias np, then our array object. Remember, guys, let me try to use something else. Let me just say something like let me say let me use anything, like let me say code, then dot array or object. Let me use object. This is the best term. Let me just say object. This is our array object. Yeah, I just want to show you to depict the fact that you can use any other variable, but it's not a must to use this one. I'm just just showing you. And then np dot array. And then in this array, we are passing what we are passing these elements, like for example 1 2 3 4 5 6 7 8 9 10, for example 11 12. So guys, I want to show you how you can reshape this one-dimensional array to a two-dimensional array. So guys, basically to reshape, I can say new. Let me say new array. Let me assign it to our object dot reshape. We want to reshape that object. Reshape. We want to reshape perhaps to to a two-dimensional array. So let's say each will have 4. Let me say 4 and then 3, 4 and then 3. So what I do, and basically in this case, when I do this, I mean that the outermost dimension will have 4 elements in the outermost dimension, but each will have 3 elements. Let me do that. Let me run so that you can see how it does that. Basically, guys, I should have done what I should have added here, the print function. Let me say print, and then I print not the new underscore array. So what I do, let me run, and then you can see it does that. So you can see now, guys, basically the outermost, it has 4, 1, 2, 3, 4. It has 4. It has 4 arrays, but in each array it has 3 elements inside each. Inside these inside these array elements. So guys, basically also you can also do the same with the 3 dimension to convert to a 3-dimensional array. In that case, guys, you have to specify. For example, you can say 2, 3, for example, then 4. Let me explain this way. So guys, basically when I use 2, 3, 4, I mean the outermost dimension will have what will have 2 arrays. It will have 2 arrays, and then and I have 2 arrays that contains 3 elements, each with 2. Basically each here should be 2 elements. Let me use that 2. That should be 2. So let me run. And then I guess you can see we have 2 arrays. You can see you have 2 arrays. Basically this is 1. Then this is 2. And then in each array, basically in each array it has what it contains. 2. It contains what it contains. Basically in this area it contains. Basically it contains not 2. It contains 3 elements. Basically in the 3 arrays, it contains 3 arrays. But in those arrays, in these 3 arrays, each has 2 elements. You can see it has 2 elements. So guys, I think you've understood that. But remember, when you converting, it must be divisible. Like you can't. Let me try to show you something here, guys. And so guys, basically guys, can we reshape it into any shape? Like for example, we can reshape into any shape as long as the element required for reshaping are equal in both sides. So guys, basically we can reshape. In this case, we can reshape an 8 elements 1 dimension into 4 elements, 2 rows in 2 rows, basically for 2-dimensional array, but we cannot reshape into 3 elements, 3 rows. We will have an error like in that. In this case, let me just show you. You can't do this. It must be equal. It must be equal for it to work. If you have, for example, 8 elements here, it won't work. Let me run. You'll get an error. You can see you cannot reshape array of size 8 into 3 into basically into 3 arrays with the 3 elements inside each. So you can see we get the error. And so you need to understand that. So guys, let me talk about iterating or iterating arrays. So iterating means going through elements one by one, and we deal with multi-dimension for arrays in Numpy. You can do this, guys, basically by just using the for loop, basically a for loop of Python. If, for example, if we iterate a 1-dimensional array, it will go through each element one by one. Like for example, let me show you an example, guys. Do I have some code somewhere? Let me just copy this one. I don't want to repeat the same thing. I think you've understood. I've repeated several times. You have understood that. Now let me show you how you can iterate. Guys, basically let's just use the for loop, the normal Python for loop. So we will say for x in this array, and then I want to do, let's say print print what, print print x. So when we run, it will reiterate everything. You can see 1 2 2 3 4 4. It has returned everything. You can also iterate a two-dimensional array, like for example, let me make here two dimension. First of all, let me do this. Let me cut. Remember I said that a two-dimensional array is an array. Remember this one defines that this one is an array, but in this array it has one-dimensional array as its element. You can have several. And then perhaps let me try to change the values here, like for example, let me say 3 4 6 8 whatever. So guys, basically if you want to iterate this one, it will do this. It will go through the number of dimensions one by one. Like it will return this one, then this one. So when we run, you can see it returns each row. It returns each row. So guys, I think you can also iterate inside the arrays by using the for inside the for loop. Like for example, you can also say here, if you want to iterate in each element, you'll have to say, for example, you'll have also to add the for example, for x in now we will use the for y, anything for y in x, then let's say print. Remember, Python is considers indentation very much, so you have to be keen in that. And then here we are passing y, and then it will do what it will iterate over these elements. You can see it has iterated over each. Now in each element, it has broken down in those arrays, and it has iterated everything. So guys, basically that's how you can do the iteration. You can do the same in the three-dimensional array and so forth, but I just wanted to help you get the concept here. Now let me talk about the other thing. Let me talk about joining the arrays. I've talked about on how you can on how you can split, for example, one dimension. I talked about that in a few. I talked about on how you can reshape, or you can split a one-dimensional array into other arrays. But now let me talk about on how you can join the Numpy arrays. Now joining means putting contents of two or more arrays in a single array, and basically in SQL we join tables based on key, whereas in Numpy we join arrays based on axis or by axis. So we pass a sequence of arrays that we want to join to the concatenate function along with the axis, and if the axis is not explicitly passed, it is taken as 0. Let me show you that. So I want to show you how you can join two arrays. For example, let me say import numpy is np alias, and then let me create array 1, then let me pass here to np dot array, and then here I'm gonna pass in this array list 1 2 3 perhaps 4, then 2 for array 2. Let me do this. Let me just copy, and then let me paste it here, but here I'm gonna change it to 2, and then here perhaps let me change it to 5 6 7 8. So we have two arrays. Now guys, basically to concatenate or to join them, we are going to use this one. Let me just say array, then let me assign it to the Numpy, the module itself, and then with the concatenate function. Now concatenate is a function inside this Numpy module. Now when you go to the Numpy, Numpy is a module itself, but inside the module we have the function called the concatenate. Now that concatenate function is used to do what is used to help us join the values. It should be concatenate, right? I don't know if this is the spelling concatenate, I think. And then here we are gonna pass in the arrays that we want to concatenate here. inside what? Inside this tuple here, it is array 1 and array 2, array 1 and array 2. And then now here the print function, let's say print print what? Print array. So let's try to run, and then as you can see we have combined, we have joined, you know. Now we can also do the same in the two-dimensional array. It will still work. Should I show you that? Let me show, but I think is you understand, you understand these stuffs. However, let me show you. But remember, for in this case you have to define the axis. Let me show you that. I think it seems complicated. Let me show you that. Let me cut, then let me paste it there, and then also let me cut this one. Now let me paste it here, and then here also this second one I have to, let me say also 3 2 4 5, and then here perhaps let's say 1 3 should be 1 3 6 7, like this. And then guys, basically in this case you have to specify the axis, and we are targeting axis 1. Let's say axis 1, and then when we run guys, you can see we have, you know, combined. We have done what we have combined, you know. So guys, I think guys you have understood that. We of course we have others like you know, stocking. We have stocking. You can find the reference. You can find the reference on the website. You are gonna find everything here in details on the website. You can just go to the Nemtech website. The website is Nemtech, Nemtech, nemtech.com. I don't know how you pronounce it, but for me, I always pronounce it as Nemtech. You consider H is silent, but I'm sure you have H at that name. So nemtech.com. So when you go to this website, and then you navigate to the Python, when you navigate to Python, you'll have what? You'll find everything there. Let me just get there. Python programming. Let me close these arts. Python programming. Then you navigate to. Let me go to the next page. You go to the next page, and then this file handling. Then here we have Numpy. So guys, basically you are going to find we are where the array shape. We were the reshaping or joining. We were the joining, right? So guys, you can see you have other stuff like joining array using stack function, and many other stuffs here, of which I'm gonna give you as an assignment. However, let me talk about the Numpy array splitting. Let me focus on the codes because I'm basically on this page because I'm teaching. Now let me talk about what? Let me talk about it was splitting arrays. Basically that was joining, but now let me talk about splitting. Now guys, basically the term splitting is the reverse operation of joining. So joining merges multiple arrays into one, and the splitting breaks one array into multiple. So we use array underscore split for splitting arrays. So we pass it the arrays that we want to split, and basically the number of splits. Like for example, here let me guys write here. Let me just say import Numpy is np alias. Then let me create an array object with the np dot array, and then here let me create an array element like 1 2 3 4 5 6 7 8 9 9, perhaps let me say 10 to 10. So now here the new array, let me call it new underscore new underscore array, and then let me pass in here what the module numpy np dot, now we use the array split, array underscore split function. Also this is the array underscore split is a function inside the numpy module, which is used for, is a function used for splitting. This one is used for splitting what the arrays. So for example, we want to split this array object here, because we named it as an array, and then I want to split it into two times, like let's use 2 times, and then here let's print out, let's say print new underscore array. So when I run, guys, you can see we have 2 splits. We have the array, this array, and then the other array. So we have split it into 2 times. So now, guys, basically the return value is at least containing the if it were it basically the return value is at least containing two arrays. In this case, you can see it is a 2 array. But I guess if the array has less element than the required, it will adjust, at the end. For example, if you want to have 3, we all know that a 3 is not divisible in 10, so it will have a remainder or something. But you can see it adjusts itself to fit to ensure that it has 3 elements, but at the end. So guys, I remember we also have another method called split, which is available, but it will not adjust the element when the elements are less in the source array for splitting, like the example that we have done here. It has also the function called split, but this one will not work, will not split if the values has a number which is not divisible. Like in this case, you can see it brings an error. Array split does not result to an equal division. But if it were something like, for example, if we split it into 2, remember 2 is divisible in 10, so it will split into 2. So guys, you can see it is important to work with what to array underscore split function instead of split, just split, and it's very, very important. So guys, basically you can split 2-dimensional array, you can split anything here, but guys, again, you can go to the website and then find everything. You can find everything here on the website on how you can split the 2-dimensional array and so forth. However, let me talk about the other thing, another thing here called what let's talk about numpy array searching. So guys, basically you can search an array for a certain value and return basically the indices that get a match. Like to search an array, we use the where clause or a where method to search for something. Like let me just do this. Let me just copy this code, the first 2 codes, and then let me paste there. And then here, let me create a new variable here. Let me call it x. That's not a good practice. Remember, I told you that. np dot, and then I'm gonna use where. And then remember, this where is used now to search. Basically, we are searching the array. This is our search term, the array. And then targeting where there's 4. For example, where there's 4, we all know that there's 4 there, so it will return the index number. And then for example, let me say print now. Let me print the x, and then guys, you can see it prints the index number is the index index 3. Remember, I told you that the index 3 is like for indexing in NumPy begins from 0, and then the data type, you can see it is the integer. You can see, so it's very, very important to understand this concept. So you can just use that. You can find the indices with the where clause or a where method, to find the indices. So guys, let me show you another example to find indices where the values are even. Like if you want to obtain only the even values, you'll have to add in the percentage here, array, then percent, and then to show this even, you use 2 for even numbers, and then begin from, let me say 0, and then you can see it returns it returns what? It returns the even, it returns what? It does returns the even values. Now the other way around should be, for odd values should be 1. You can see it returns basically the odd values. So guys, basically we also have the search sorted. Now basically this search sorted method performs a binary search in the arrays and returns the index where the specified value would have been inserted to maintain the search order. Let me just show you an example before we go to something else. Like guys, basically the search sorted method is assumed to be used on sorted arrays. Like for example, let's disorganize these stuffs. Let me just say, for example, 7, 6, 2, 5, 9, 3, should be 3. So guys, basically search sorted, we can do this. We have to add in this method here. Should be search sorted, and then array, and then what I do, let me say first of all, add in that. Let me add in 7. So it will print what? It will print the index number of 7. So it will be so you can see it does what it prints. It prints. It has printed out 6. Basically, the index where the value should be inserted. Basically, the value 7 should be inserted, so it should be at the 6, right? At the 6. Do you understand the concept here? So basically, let me talk about this. Let me try to explain for you to understand. So guys, basically, the number, this number 7 should be inserted at the index what? At the index, at the index 6 to maintain the order, because the 6 is kind of is less than 7, so it should be inserted here to maintain basically to maintain that order. But the method starts the search from the left, and I return the first index where basically this number 7 is no longer larger than the next value. So if it were 8 here, you can see it should be. It should basically it has picked it out. Let me change here to 9. So you can see it should be at the 0. You can see. So guys, basically this how you can work with that. So you can already specify the side. For example, if you want it to begin from the other side, you have to specify that argument called side, and then you specify. For example, if it's right, you just say right, and then it will do its thing. Then you can see it does that. But guys, let me talk about the other thing here. Let me talk about what should I talk about? Let me talk about the sorting arrays. I think that's the next thing. Sorting arrays. So guys, basically, how do we sort array? So basically, sorting means putting elements in an ordered sequence. Ordered sequence is any sequence that has an order corresponding to the elements, like the numerical or alphanumeric, ascending or descending, such stuff. So like for example, this one is our random number. Let me add in several, 10, perhaps 4 is on there. So guys, basically I want to sort this array to be in an ordered format here. So guys, basically in that case, let me just delete this stuff so that it will not confuse you. In that case, guys, here the print function, you have to say np dot sort. You'll have to use this method, and then you target the array that you want to sort, array object, which is array, and then when you run, You can see it's now in an ordered sequence: 1 2 3 4 7 9 8 9 and so forth. So guys, basically this is how you can sort. You can also sort the strings, like example, let's say for example banana, and then apple. Apple should be inside the quotation to define that this one is a string, and then for example something like a cherry. Now when we run, it will begin with apple, banana, cherry equals A, B, C. It goes in that order, in the alphabetical order. You can also do the same with the booleans, but guys, you can do the same. You can try everything here, or you can find everything at the website. But I think up to this point, guys, you've understood the sorting, basically the sorting NumPy arrays. So guys, let's now talk about the NumPy random, and NumPy random is a very important part that you need to master in this NumPy course. So first of all, let's understand what is a random number. A random number. Basically, a random number does not mean a different number every time. A random number means something that cannot be predicted logically and predicted, basically numbers. So basically we have the pseudo random, and also we have the true random. Now computer works on programs, and the programs are definitive set of instructions. So it means there must be some algorithm to generate a random number as well. So basically if there's a program to generate a random number, it can be predicted. That is not a truly random. So basically random numbers generated through a generation algorithm are called the pseudo random. But can we truly make can we make truly random numbers? Basically we can. In order guys to generate a truly random number on our computers, we need to get the random data from some outside source. So this outside source is generally our keystrokes, mouse movements, data on network, and so forth. And guys, basically we do not need truly random numbers unless it is related to security issues like encryption key, or the basis of application in the randomness, and basically perhaps the digital roulette wheels and so forth. But then guys, basically in this tutorial, we are gonna basically in this course we are gonna focus on the pseudo random numbers. So first of all, I want us to begin by first generating a random. I want to show you how to generate random numbers. And basically NumPy offers a random module to work with the random numbers. So without further ado guys, let me show you. And so this one is a submodule. Random is a submodule of NumPy. So in order to use it, you have to use this keyword from NumPy. From NumPy, import random. Import random. Now we can create now our object with these random numbers. So let's say random random dot run, basically run it. Basically run it should be empty, and then here we can generate some random numbers around 100. Let's try 100. Then what we do, let's do at least print. Let's say print print that text. You said guys that is a good practice to use descriptive names to define a variable, but for the sake of tutorial, let me just used that. And then guys, basically you can see at a range of 100, between 0 and 100, we have generated a random number which is 84. When we run again, it will print something else. When you run again, it prints something else. So basically this is how you can generate a random number, but we have specified the range. You can also specify if it's 10, it will only return at this range of 10, 8, and then 8. You can see it repeated 8 twice. So this tells you that a random number does not mean a different number every time. It's something that cannot be predicted, logically. So guys, you can see this is how you can do it. This is how you can generate a random numbers, basically a random integer and the range of 0 to basically 0 to 10. Now for float, basically guys, for float we are gonna do this. We are gonna use basically this one is rand integer, but now for float, you can say for float you just say rand. It will return a floating number. So you can see it return the floating numbers at this range, but now in this case guys, you don't have to specify. We don't have to specify these are float, so it will return from 0 to 1. When I run again, it return, but it will not surpass 1. So the range, basically the random modules rand method returns a random float between 0 and 1. So let me show you guys how you can generate a random array. So basically Numpy work with arrays, and you can use the two methods from these ones, these ones that I've just showed you to make random arrays. You can use the rand integers, and basically this method takes the size parameter where you can specify the shape of an array. So like for example, let's generate a one-dimensional array containing perhaps 5 random integers from a range of perhaps 0 to something like 100 again. So in that case guys, here we are gonna do it rand integer, random integer, rand integer, and then here we are gonna specify the range, and then the size of the size. Let's give it, I can give it 5 what to have 5 elements. I think let me give it 5, and then what I do, let me run. So guys, basically you can see it has given us this one-dimensional array with 5 elements inside it, and then but the range is between 0 to 100. And so guys, basically this is how you can generate the array from these random numbers. Now for two-dimensional array guys, you have to do what you have to specify. You have to specify. You have to use you have to use specify. You have to use these two parameters. The first one, and then the number of elements in each array list. And then when we run, and guys, you can see it is basically it is a two-dimensional array, but it has what? It has 3 elements inside it. In each element, it has 5 elements. Now for float guys, you just use what? You just use rand without the integer like this, and then in that case guys, here you have to do what? Here you have to specify the number, basically the number of elements that you want to return for a one-dimensional array, and then I guess you can see it has returned 5 elements. So for a two-dimensional array with floating numbers, what you do is specify first of all the number of arrays, the number of first one-dimensional arrays that you want to return, and then the number of elements in that one-dimensional array, and then guys, basically you can see it has returned a two-dimensional array with 3 one-dimensional array elements inside it, and then in each array element, in each one-dimensional array elements, we have 5 floating numbers or 5 elements. So guys, how can we generate random numbers from an array? So guys, basically you have the choice method, which allows you to generate a random value based on the array of values. Like the choice method takes an array as the parameter and randomly returns one of the values. For example guys, let me show you. Let me copy this first line of code, and then what I do here, let me create a variable. It's a good practice to use descriptive names, but let me say random dot choice, a random dot choice, and then here I'm gonna pass in an array list or some random values. So guys, basically when I print out, let me say x, and then I guess basically when I run, it will print the random numbers but in this range. So you can see 9 is available here. So let me try to run again. You can see it has bring out a 9 again, basically 9. So first of all, let me run again. You can see it is 5 again this time, 5 again, and then a 1. So just a random number but in this range. You can see we have 7 here. So basically this is how you can do it. This is how you can generate a random numbers from an array, a specified array. So basically the choice method allow you to return an array of values, and as the size to specify the shape of the array. You can also do that. For example, let me do it. Okay, so let me show you, for example, how you can generate a two-dimensional array that consists of values in the array parameter. Like what I do here, guys, so let me add in another parameter here, and then I define the size. I say that the size parameter is used to specify the shape of the array. So here I want it to return what I want it to return. A two-dimensional array that has 3 one-dimensional array, and in each array we have what 5 elements. 5 elements in it. So what I do, let me try to run, and then I guess you can see it has done what it has done. So it has returned a two-dimensional array with the 3 elements, 3 one-dimensional array elements, and then in each array elements we have what 5 these are elements. So guys, basically this was just the basics of random introduction. But now let me talk about the random data distribution. Basically, first of all, what is a data distribution? A data distribution is a list of all possible values and how often each value occurs. So such lists are important when working with statistics and data science. So basically, the random module offers a method that returns randomly generated data distribution, and random distribution is a set of random numbers that follow a certain probability density function. Talking about a probability density function, what is it? Basically, this one is a function. Probability density function is a function that describes a continuous probability, or a probability of all values in an array. So basically, you can generate random numbers based on the defined probabilities using the choice method, basically of the random module. Remember, random is as a module of Numpy. And so basically, the choice methods allow you to specify the probability for each value. Like the probability is set by a number between. Remember, probability cannot surpass 1. So it is either between 0 and 1. And 0 means that the value will never occur at all, and then a 1 means that the value will always occur. So if you have a higher value, it means there's a high chances of that probability to occur. So I want to show you an example here, guys, without further ado, how to generate a one-dimensional array containing perhaps 100 values, where each value has to be either some specific values like even 3, 5, 7, or anything. And then the probability for the values to be 3 in the set of, in the basically the set to be perhaps 0.1. Let me just show you that. So first of all, what I do, let me just say from Numpy import import what? Import random, and then here we are going to create our object with variable x, and then let's say a random dot choice, and then I want to specify the choices that can be used for our random. So guys, here I can say perhaps let me say 3, 5, 7, 9. So guys, basically when I do this, it will mean that I'll want to generate, I'm gonna specify another parameter, let's say parameter here to be 100. So in that case, guys, it will mean that that one-dimensional array will contain 100 basically values, where each value has either to be in this range, has either to it should have only these 5 values. These are 4 values, either 3, 5, 7, and 9. So guys, let me add in those other parameters. So for example, the probability we define it using the p, and then here we specify what? Sorry, we specify the probability, for example 0.1. This is the first one, 3. The probability of 3 occurring, and then the probability of 5 occurring, I can say 0.3 perhaps, and then a probability of 7 occurring. This 7 I can give it what? Let me give it a 0.6, and then the probability of 9 occurring, let's give it 0.0. So guys, basically in that case it will mean that 9 will never occur at all, because the probability is 0. There's no chance for it to occur, but the values or the size to be returned should be 100. So let me say size, I'm gonna assign it to let me assign it to 100. Let me assign it to 100. Then what I do, let me print out. Let me say print. Let me say print x, and then what I do, let me run, and then I guess basically you can see I've returned. These are 100 values here, as you can see, but you can see there's no 9 somewhere, because its probability was 0.0. For example, if you want to, you can see 7 very many, because its chances is high, 0.6. But if we change the 7 to be 0.0, then for 9, if we give it something like a 0.9, basically we will have several of 9s here. So let me first of all a numpy random probability do not sum to 1. The probability do not sum, I think there's an error somewhere, right? So okay, so basically sure, these probabilities, when you count it, it should do what? It should reach 1, basically 1. So for example, if I give it 6 and then I run, you'll have several of 9s, and you'll not find any 7 number here. So guys, basically you can see this is how you can do it. This is how you can generate random numbers from a defined set of values that you want to return. So guys, basically the other thing that you must consider here is that this number of probabilities that you have defined here should be, when its summation should be 1. It can't surpass. So even if you return basically this number, perhaps even 100 times, the value of basically the value of 7 will not basically the value of 7 will not occur, because the chances is 0.0. So guys, basically let's talk about something else. I think up to that point, guys, you've understood. Let me talk about the random permutations. Now, random permutation of elements, or a permutation refers to arrangement of elements, like for example 3, 2, 1 is a permutation of perhaps 1, 2, 3. And then basically Numpy random modules provide two methods for this. We have the shuffle, and then we also have the permutation. Let's begin with the shuffling arrays. And shuffle, guys, remember shuffle means changing arrangement of elements in place in the array itself. Like guys, let me show you first of all that example. So first of all, let's import what this module submodule called random, and then because we want to have an array list here, we're going to use also numpy. So let's say import numpy. I import numpy is np alias, and then here guys, let's create our array. Perhaps let me call it array, and then let me assign it to the numpy array. And then in this array list, I'm gonna give it some values, some set of values, 1, 2, 3, 4, perhaps to 5. And then I want to shuffle it. I want to use the random shuffle. So let me say random dot shuffle. The spelling for shuffle, I think it's this way. And then we want to shuffle at that array object. And then what I do, let's print. Let's say print. It should be array, right? Should be array. And then what I do, let me try to do it. Let me try to run And then again, basically you can see we have shuffled these tabs, and you can see it's 1, 3, 2, 4, 5. We have just shuffled it. Let me run again. You can see it is now shuffled. The arrangement is interfered. So basically the shuffle method makes changes to the original array. Now let's talk about how you can generate permutation of an array, or how you can generate a random permutation of elements with a certain array elements. Like guys, basically for permutation guys, here you can just change here to we can just change here to permutation, right? Permutation. What I do when I run, you can see it gives us these are values. So basically permutation methods returns rearranged array, and I leave the original array unchanged. So like I can see it has rearranged in an organized manner. So let me talk about another thing here, guys. Let me talk about the seaborn. Now basically seaborn is a library that uses matplotlib underneath to plot graphs. It will be used to visualize random distribution. So it's a very important part of data basically visualization of distribution with basically to visualize data or graphs or such stuff, so our values. So first of all guys, before you work with the seaborn, you have to install it. But if you're using Anaconda, it usually comes with those packages. You don't have to do that, but let me show you how you can install it. So what you do, you just go to your terminal, and then on your terminal or a command line tool, just type in a pip. Remember I told you pip is a package manager to install Python packages. So pip install seaborn, should be seaborn, right? Seaborn. Then when you click on enter, then it's going to install that seaborn for you. So let's give it some time to install. So guys, basically depending on your internet connectivity, it can take some time. However guys, this is how you can do it. This is how you can install it. Let's close this window here. Now guys, basically once you've installed it, to import it, you just use, remember this one is I said that seaborn is a library that uses matplotlib underneath. So first of all, you have to do what you have to import the seaborn. If you want to use it, you have to import the matplotlib and also the seaborn. So guys, basically let me talk about these plots in a few. This plot stands for distribution plot, and it takes It takes as input an array and uploads a curve corresponding to the distribution of points in that array. So first of all, guys, let me show you how you can import the matplotlib. I think I have a full course on matplotlib. I have a series of tutorials on matplotlib, a full course basically on matplotlib. However, I'll provide also a full course like this one so that you may find it easier to learn it in a single video. However, guys, basically this is how you can import matplotlib. This one is for data visualization mainly. So let me say import matplotlib, but you can't use matplotlib alone for data visualization. You have to use this other submodule called pyplot, and then we can use it as an alias because we can see it's kind of a long name. So to use it and the way it is kind of hectic. So you have to use it as an alias like a PLT. PLT is a default one, and then matplotlib.pyplot. So basically, this is how you can import matplotlib. Now also to import the seaborn, the seaborn, guys, you just do it. You say import seaborn. You can also use it as an alias, perhaps SNS or any other alias name. Now let me show you guys now how you can plot something, or you can visualize something. So first of all, you can say SNS dot this plots, and then what you do is let's plot some values that we want to use it in that visualization graph. We can say perhaps let me use a 0, perhaps 1, 2, 3, 4, 5, and so forth. And then now here to visualize, here we don't use the print function, we now use the plt. Remember that they alias for matplotlib.pyplot, and then here dot show. Now show is a function to visualize, and then what I do, let's try to run and see if it will work. Let's give it some minutes for it to work. And guys, basically you have to have the matplotlib compilers for it to work, like a tkinda. But I think if you have Anaconda, it usually come with those packages, will not strain a lot. But guys, basically you can see it has done what it has, visualized this graph. You can see. So you can also do that without. You can see it has come with a graph, basically with a histogram. So you can also do away with the histogram by defining by adding this other parameter. Let me zoom in a bit. And by adding another parameter called hist. First of all, separate parameters with a comma, and then I say hist. You assign it to a false value, a false boolean, and then what we do when we run, we will not have that histogram again. You can see it's no longer available there. So basically, this is how you can do it. This is how we can work with this seaborn. However, guys, basically we will be using sns.displot, and then array in your array list, and also the list false, and to visualize random distribution for this, specifically for this portion of for this course. So guys, let me talk about another fundamental thing here. Let me talk about the normal distribution. Sometimes it is called the Gaussian distribution. Now, basically, the normal distribution is one of the most important distribution, and it is called the Gaussian distribution after that German mathematician called Carl Friedrich Gauss. So basically, this one fits the probability distribution of many events like the IQ scores, heartbeats, and so forth. So we use the random dot normal method to get the normal distribution. It has 3 parameters. The first parameter is log, which is mean, where the peak of this is the peak of the perhaps where the bell exists. And then at the scale, this is the standard deviation, how flat the graph distribution should be. And then at the size, this one is the shape of the returned array. Without further ado, let me show you that. First of all, I said we do what? Let me zoom in. First of all, you have to import the modules. So from Numpy, import random, and then let's create our object with the variable. Any other variable you can use descriptive name. I'm teaching, but for you, ensure that you use the descriptive name. So let me say random, a random.normal, then here you have to specify the size. So size I can give it perhaps size, let me give it a 2 dimension, let me give it 2 by 3, so it will have two one-dimensional array, and in each array elements it will have 3 elements in it. And then here what I do, let me say print. First of all, let's print out. I'll show you how to visualize later, but let me just show you how to, it will look like. And then I guess basically you can see it has returned a two-dimensional array, and then in each array you have 3 elements, so you can see how it looks like. Now guys, basically let's generate a random normal distribution of size, perhaps a two-dimensional, basically a 2 by 3 with a specified mean, perhaps 1, and a standard deviation of a certain value. So guys, basically in that case you have to add in other parameters called what? We begin with the log. I said log is like what? Log is like at the mean where the peak of the bell exists. And then I said also scale. Scale is the standard deviation, how flat the graph should be. And then what else? I said the size. Now this is the shape of the returned array, and you can see it is a two-dimensional array in this case with 3 elements in each array element. Now what I do here is now let's specify the log, or rather the log, basically the log or what, or the mean. And then let's give it perhaps 1, the mean to be 1, and then the scale or a standard deviation, and we can give it what, let's give it even 2. And then the size parameter is a two-dimensional array with 2 elements in it, and in each element will have 3 uh, 3 elements, So what I do, let me run again and see the output. You can see we have this kind of an output. Now how do we visualize this stuff? So to visualize here, we are not going to use the print function. We'll use what? I will use what? Let's do this. Let me first of all remove the print function, and then here we are gonna do this. We are gonna first of all, let me do this. Let me say SNS. First of all, guys, in that case we'll have to import several modules here. First of all, at the random, and then also we'll need to have the matplotlib. Remember, matplotlib is a function, is a module for visualization. So it's should be import matplotlib.pyplot. Matplotlib.pyplot is a plt alias plt, and then also we will need to import what, the seaborn. So import seaborn is what, is SNS. Now once you have defined that, here we can say SNS dot distplot and then here you can do it, you can pass in that random dot normal distribution, and then with the perhaps let me remove these other parameters. I think it might confuse you. Let me just remove them and retype it again. So random dot normal, and then here we're gonna pass in the size parameter. So let me say size. Let me use perhaps let me use 1000. Then I remove the histogram. How do we remove the histogram? By defining hist and giving it what, a false boolean, false value, false. And then now when to visualize, To visualize, guess which function do we use to visualize? It's not a print function, of course. It is PLT. Remember, PLT is the alias for matplotlib.pyplot. Here it is. And then now here we say show to visualize. And then now when we run, we'll have that graph here. So let me zoom out a bit. And then I guess basically you can see it has returned this graph. So basically the curve of a normal distribution is also called the bell curve, because of the bell shaped curve. Now, so guys, let me talk about the binomial distribution. Now, binomial distribution is a discrete distribution. This one describes the outcome of a binary scenario like a toss of a coin. It will be either head or a tail. It has basically three parameters. You have n, the number of trials, p, the probability of occurrence of each trial, like tossing of a coin, basically 0.5 each. Basically the probability is 0.5 each, and then at the size, that's the shape of the returned array. So I talked about the discrete distribution. First of all, let's understand, it's better for us to understand first of all what is a discrete distribution. And this distribution, basically the discrete distribution is a separate set of events. For example, I said a coin toss results is a discrete as it can be only head or what, or tails, whereas a height of people can be continuous as it can be certain inches or feet and so forth. It can be perhaps 170, 170.1, 170.11 and so forth. So like guys, let me show you an example here. Perhaps given you have 10 tries for coin toss, you want to generate what 10 perhaps data points. So what you do guys in that case, let me zoom in, and that gives let me say from Numpy import, we're going to import random. I'll show you how to visualize later, but first of all, let's understand the concept behind it. And then first of all, let me say create a variable. As I said, you can use descriptive variable names to define your object. Then let me say random dot binomial. And then here we're gonna do this. Let's say n, then assign it to remember I said n is what? N is the number of trials. So this one will be 10 trials, and then what? This will be 10 trials, and then if you specify p probability is either half, 0.5. A contours is either head or tail, so the probability is a half, 0.5. Then at the size here, this is the shape of the returned array. Perhaps you can give it 10. Of course, it should be 10 size. Let's give it what? 10. Let's print out and see the outcome. Let's print. Say print. And then we're printing what? X, or your object. Then let's run. And then again, basically you can see it has given us this kind of a result. But how do we visualize? Guys, basically to visualize, guys, you have to do it. Should I type it again? So let me just copy. I'll copy this one, and then do it. Let me just should be sorry. Let me just type it so that you can understand everything. So let me say import matplotlib. Should be matplotlib.pyplot. If you don't understand, you can always find reference on the website, the Nametech website. I think you at this point, at this juncture, guys, you understand how you can find the Nametech. Let me show you that. You can just go to Nametech, NEHM Nametech, nametech.com, and then when you hit enter, you're gonna find these websites, and then you navigate to Python. Remember, this Numpy is strictly for Python, but remember other stuffs are written in C++ in the C programming. However, find these basically the reference in Numpy. Just when it opens, you'll navigate to the Python section. You'll navigate to the Python section. Of course, here we encourage you to subscribe to this channel, to this to the name tag, so that we may notify you whenever we upload new content. However, just navigate to Python, and then where is it? Python. Then go to the next page, until you reach what you reach NumPy. However, in this case, guys, it is a matplotlib.pyplot as a what plt alias, and then also we need to import the seaborn to visualize. So let's say import what seaborn. Import seaborn is an alias as and as seaborn, and then here guys, basically to visualize here guys, we're going to use this s and s, the module, the alias for the module seaborn, and then this plot, and then here we're going to do it. We're going to pass in a random dot binomial, and then you specify these parameters. And remember, this n is the number of outcomes, or basically the possible outcomes for tossing coin 10 times. And then after this guys, also we can remove the histogram. How do we remove the histogram? By defining hist, and then giving it a false value, false. Let's give it true, right? First of all, let's give it true to see that histogram, and then also we need to also add this other parameter, the KDE. Let's assign it to false. Let's give it false. And then you always remember to close. Now here we will not use the print function. Remember, just print function is used to execute the codes at the terminal. However, if you want to visualize, you have to use this plt function, plt.show function to visualize. Then when we run, we'll have this kind of a graph. You can see it is so nice. So guys, basically this is how you can do it. This is how you can visualize. However, let's understand the difference between the normal distribution and binomial distribution. Now guys, basically the main difference is that the normal distribution is continuous, whereas guys, basically the binomial is discrete. But if there are enough data points, it will be quite similar to the normal distribution, which basically with the iconic lock in the scale. Should I show you that guys? What I do guys, let me just try to show you that. Let me copy first of all this one. Let me copy this one, and then I do it. Duplicate. Let me paste it here. I don't know if you can see. Let me try to zoom in a bit. Let me I'll zoom in a bit, guys. So first of all, the first one, let me change here to normal. Let me change here to normal. The lock, I can give it so here I use lock, right? Let me say lock. Let me give it what? A lock. I'm gonna give it let me give it even 15. And then here we use the scale or the standard deviation. So scale, in the normal distribution we use scale, so I can give it 5, the standard deviation. And then the size, let it be what? Let it be 1000 as it was. And then histogram, should it be there? Histogram, let me give it a false. Let me just give it false. Let me try to zoom out a bit. And then the label here. So for comparison, let me use the label. Label I should have used, is a built-in keyword. Let me say label. Let me assign it to what? Normal. The label is normal, And then this other one is what? This one is binomial, right? This one is binomial, and then the size is let me give it 100. Should I? Let me give it 100. And then what else? Probability, let me give it 0.5. Then size I can increase so that it can be the same, 1000. Then Instagram, let me also remove. Let me remove, and then label. For comparison, let me say label. Let me assign it to what? Let me assign it to binomial. Let me assign it to what? Let me assign it to binomial. And then I guess basically what I do here, let me try to run and see that you can check the comparison. You can see here there is an error. This plot got an expected keyword label. Oh sure guys, basically there's I think there's a misspelling here. The label should be A, right? Label. Let me try to run again and see if it will work. Yeah guys, it does. You can see they are almost the same. You can see in this case. So basically let me remind you the difference. I said the difference is that the normal distribution is continuous, whereas the binomial is discrete. But you can see here it's almost the same because we have the enough data points. So it's kind of quite similar to normal distribution with certain log and scale, because we defined them. However, guys, basically this is the difference. The main difference is that the other one is continuous, the other one is discrete. However, let me talk about something else. Let me talk about the Poisson distribution. Now, basically, Poisson distribution is a discrete distribution. It estimates how many times an event can happen in a specified time. So, for example, if someone eats twice a day, what is the probability he will eat thrice? So you can see such a Poisson distribution, or such a um, yeah, basically that is a Poisson distribution. And then guys, it has two parameters. That is, the first one is lam, or this one is the rate or non-number of occurrence, like a true of the true basically for above problem. And then a size, that's the shape of the returned array. Okay, so let me show you an example how to generate a random of perhaps 1 times 10 distribution for occurrence of true, perhaps to eat twice a day. So what I do, let me zoom in a bit, and then let's say from what? Let me say from Numpy, not really from, yeah, basically it shows from Numpy import random. And then here we can create our object with variable x or any other descriptive variable name. And then random dot Poisson. Is it Poisson or Poison? Poisson, I think. Then here you have to specify the lam parameter. I said the ram is the rate or the non-number of occurrence. Like this guy can eat what? Can have 2 meals a day. So you can say lam. We assign it to 2. Yeah. So some people can't afford meals twice a day. So here let me say size of the returned array. Let me give it perhaps 10. Let it may return us 10 values of that occurrence. So let me say print print the x. Then what I do, let me run, and then I guess basically you can see now the range is between 0 to 2, basically 0 to basically you can see now the occurrence or the probabilities very very much low on for having 3 minutes a day. So let me show you how you can visualize. Now guys, basically to visualize you have to do what you have to. Let me copy some parameters here so that we can't repeat ourselves every time. So let me copy. then I do what? Let me paste it there. And then here guys, basically I'm gonna use the SNS. Remember this is the submodule, the alias name here. Then here we can say this plot. This plot, and then here we're gonna pass in what? Let's pass in random. Let me pass in random.poisson. Random.poisson. Then here we're gonna add in this parameter or the occurrence or the rate of occurrence, lam. Then assign it to 2. And then the size of the returned array, I can give it even basically the size, let me give it 1000. And then let's remove what? Let's remove the KDE. Let's remove the KDE. Let's assign it to false. Let's assign it to false. Now to visualize, you can see so guys, basically here I think I should have done what I should have closed. Remember, I should have closed, right? So that, yeah, to close here, and then to visualize gives you use that. No, the problem here. So it is plt dot show. And then let's try to run and see the outcome, guys. Basically, you can see the outcome here, the results here. So guys, basically what is the difference between the normal distribution and the Poisson distribution? So for normal distribution it's continuous, whereas a Poisson is discrete. That's the difference between normal and the Poisson distribution. But now what's the difference between a binomial and a Poisson distribution? You can see both are discrete. So you can see binomial distribution has only two possible outcomes. It's either, for example, if you toss a coin, it's either head or tail. However, Poisson distribution can have unlimited possible outcomes. So that's the main, difference. So let's talk about something else. Let's talk about the uniform distribution. So guys, let's now talk about the uniform distribution. Now guys, basically the uniform distribution is used to describe the probability where every event has equal chances of occurring. Like for example, generation of what? Random numbers. So it has three parameters. A, that's the lower bound, default is 0.0. B is the upper bound, the default value is 1.0. And then at the size, that's the shape of the returned parameter. Let me show you that just now. Let me zoom in a bit. Then here guys, first of all, you have to do what? You have to import the module from Numpy import random. Import random, and then here let's say create our object in the variable x, and then let's say random.inform, then specify the size we can give it what, let's give it a two-dimensional array. Let's give it 2 by 3 so that it may have a 3 to be a two-dimensional array, but it has two one-dimensional array, and in each array element it will have 3 values or 3 elements. So let me say print print x. Then when I run, guys, basically you have this kind of results. So how do we visualize? Now to visualize, again, let me copy what? Let's do our thing. Let me copy here. Then here let me paste. Sorry. Let me paste it here. And then what I do here, let me get let's say SNS. Remember this is the alias for the seaborn. Then here let's say this plot. Then here we're gonna pass in our random numbers, basically our random.uniform. This is uniform. And then here we have to specify the size. Let's give it what? Let me give it 1000 again. Remember, you must assign for it to work. And then here let's separate, and then also let's remove the histogram by using hist to be a false value. To visualize, we use the plt.show function. let's run. Let's run. Then again, you can see the results here. You can see the results here. So guys, basically this is all about what this is all about, the uniform distribution, and I say that this one is used to describe the probability where every event has equal chances of occurring. Now, guys, let me talk about the logistic distribution. Now, for logistic distribution, this one is used to describe the growth. It is used extensively in the machine learning, in logistic regression, in the neural networks, and so forth. It has three parameters. You have the log, the same as the mean, where the peak is defaulted to 0. Then at the scale or at the standard deviation, this one is the flatness of the distribution. It defaults to 1. Then at the size, this is the shape of the returned array. Like, let me show you guys how to draw 2 by 3 samples from a logistic distribution with a mean of perhaps 1 and a standard deviation of 2. Let me show you that without wasting your time. From a Numpy imports random, right? We import in random, and then let's create our object with variable x, and then let's say random dot logistic Then I said it has how many parameters? It has 3. First one is log or the mean. We can give it to 1, and then for scale or a standard deviation, you can give it even 2. And then for size or the shape of the returned array, we can assign it to a two-dimensional array with a two one-dimensional array in it. And in each array element, you have 3 elements in it. So to visualize, you can say print. You can say print what our object. Then let's run, and then you can see it has given us these results, guys. But let me show you how you can visualize. Again, let's do the same thing. Let's copy the codes, and then what I do here, let me paste, and then here, guys, basically I'm gonna change here to let me just copy again this line of code. Remember, I don't want to repeat myself. Then here let me paste, but here I'm gonna change here to basically to should be logistic, right? Logistic, right? And then the size, we are giving it 1000. The histogram we are removing. Again, to visualize, we use plt.show function. Then when we run, it will do it. It will print out this logistic distribution. Now, what's the difference between logistic distribution and the normal distribution? So basically, guys, both distribution are near identical, but now logistic distribution, you can see they both have bell-like shape, but the difference here is that both the distribution, first of all, both distribution are near identical, but for logistic distribution, it has uh, more area under the tail. It has more area under the tail, meaning that it represents more possibility of occurrence of an event further away from the main. But for higher values of scale or a standard deviation, the normal and the logistic distribution are near identical, apart from the peak. So let me talk about another thing here, guys. Let me talk about the multinomial distribution. Now, multinomial distribution is a generalization of binomial distribution. So this one describes outcome of multiple, basically of multinomial scenarios, and like binomial, where scenario must be only 1 or 2. For example, a blood type of a population, basically the blood type of a population, a dice roll outcome, and so forth. This one has 3 parameters. It has n. N defines the number of possible outcomes. It can be 6 for a dice roll, and then p volts. This one is the list of probabilities of outcome. It can be perhaps 1/6, and if you remember, the probability of a dice roll is 6. There are 6, so the probability for each, it can be either 1/6, 1/6, 1/6 for each until it reaches 6. And then at the shape, this is the shape of the returned array. Now let me show you an example, guys, of basically how we can draw a sample for dice roll here. So what I do here, guys, let's say from numpy import random, or from numpy import random, and then here let's create our object with variable x. Then here let's say assign to random dot multinomial, right? Multinomial. Then here we're going to pass in what n. I said is the number of possible outcomes. I can give it perhaps 6. For dice roll is 6, right? And then now the pivots. I say this is the list of probabilities of outcomes. So for dice roll, it can be for 6, it can be 1 over 6, right? It can be 1 over 6, comma 1 over 6. How many 1 over 6? Should be 6, right? 2, 3, 4, 5, 6, right? And then what we do, let's print out. We say print our object x. Then let's run, and then you can see it has given us these results. Also, you need to note that the multinomial sample will not produce a single value. They'll produce one value for each pivot. Pivot. So guys, basically as they are generalization of binomial distribution, their visual representation and the similarity of normal distribution is the same as that of multiple binomial distribution. That's why we don't have to test that. We don't have to draw that to visualize that, because they just the same. Now let me talk about the exponential distribution. Now guys, basically exponential distribution is used for describing time till next event, perhaps failure or a success. It has two parameters, and the first one is scale or inverse rate. Scale, this one is the inverse of rate, and basically this one defaults to 1. Then we also have another parameter, the second parameter, which is the shape, the size, which is the shape of the returned array. Like let me show you guys an example here. First of all, let's import. What I do here, let me just copy, let me paste it here, x, then let me assign it to random dot exponential. It should be exponential. Then here we are going to give it the scale of what? Scale, I said this one is the inverse of rate, so let me give it scale of what? Let me give it 2, and then size, a two-dimensional array with a two one-dimensional array in it, and then 3 elements in each one-dimensional array. And then let's print out. Let's say print x. Then when you run, you can see, guys, it gives you these results here. How do we visualize? To visualize, it's just easy. Let's copy the code, and then do what? Let's paste it here, and then here, guys, basically we're gonna do this. Again, I think also I should have copied this line of code, or everything. I should have just copied everything, and then here let me just paste. But now here we're going to change here from logistic to exponential. Let's change to exponential. Exponential, right? Exponential like this. Then the size, let's give it 1000. Then the histogram, let's remove it. Then let's try to visualize and see the outcome. So guys, basically you can see the results here. You can see it is You can see the results here. So let's understand the relationship between the Poisson and the exponential distribution. Now, Poisson distribution deals with the number of occurrence of an event in a time, basically in a time period, whereas this exponential distribution deals with the time between these events. You know, that's the difference. Again, Poisson distribution deals with the number of Poisson of basically of occurrence of an event in a time, basically in a time period, while this exponential here distribution deals with the time between these events. You know, I think this is the main difference. And then there's another type of distribution that I want us to talk about here is the chi-square distribution. Now, first of all, what is a chi-square? Basically, a chi-square distribution is used as a basis to verify the hypothesis. It has two parameters, df, that's the degree of freedom, then at the size, that's the shape of the returned array. Without much ado, let me show you how to draw out a sample of a chi-square distribution with a degree of freedom of perhaps 2, and then at the size two-dimensional array 2 by 3. And so what I do, let me do it. Let me just should I just copy the code somewhere here? Let me copy, and then let me paste it here for the sake of time. And then here I'm going to change it to from exponential to what? To chi-square. To chi-square. What is spelling for square? I think it's this way. And then here we're going to change here the parameter. It is df, degree of freedom, df, and then give it 2. Then the size, let it be a two-dimensional array. And then you can see the results here. But then let me show you how you can visualize. Now to visualize, guys, again let's copy, because codes are almost the same. And then here, instead of exponential, it is what? It is it is a chi-square, right? Chi-square. A chi-square, right? Like this. And then here we're gonna add in this parameter called the df, degree of freedom. I'm gonna assign it to, let me give it to 1. Says let it be 1000, then the histogram to be false. Then let's try to visualize. So guys, you can see the results here. You can see the results here. So basically, this is how you can do it. This is how you can this is the chi-square distribution. This one is used just as a basis to verify the hypothesis. Okay, so basically the other thing here I want us to talk about is the Rayleigh distribution. Basically, the Rayleigh distribution is used in signal processing. It has two parameters. It has the scale, that's the standard deviation. This one decides how flat the distribution will be. It defaults to 1. And then if you don't specify it, it will default to 1. And then at the side is the shape of the returned array. And let me show you guys an example how to draw out a sample of a Rayleigh distribution with a scale of perhaps 2 and a two-dimensional array here. What I do, let me say, let me just copy, paste, and let's copy paste, and then here we're changing to Rayleigh. Let's say Rayleigh, and then here guys we are removing from degree of freedom, we are changing to scale. It has only scale parameter and the size. The size is the shape of the returned array. What I do, let me run, and then again basically you can see it has printed out these results. And to visualize guys, we do what? We just copy somewhere. We copy the code somewhere like this. Remember guys, these are just the same things, and I think by now I believe you have understood how to write in these codes. So for the sake of for the interest of time, guys, I'm just copying and pasting, though is not a good practice, but for the interest of time, let me do this. Forgive me for these ones. Forgive me these ones. I'll repeat it again. Also, let me say Rayleigh So let me say array, and then the size I give it 1000. The histogram I remove it, and then let me run. So you can see the results here. So guys, basically you can see now there's some similarity between the Rayleigh and the chi-square distribution. You can see at a unit, a standard deviation and a 2 degree of freedom Rayleigh and chi-square represent the same distribution. You can see it's almost the same. So let me talk about now the Pareto distribution. Basically this one is a distribution following the Pareto's law, like 80-20 distribution, 20% factors cause and then 80% outcome. It has two parameters. It has A, that's the shape of the parameter, and then a size, that's the shape of the returned array. Let me show you that, how to do that. Again, let's do our trick. Copy, and then what I do, let me paste it here to this a new cell, and then here guys, I'm gonna change here to Pareto. Should be Pareto, right? Pareto like this. Then here the first parameter is A, and I said A is what? This is the shape of the parameter, and then is 2. Let's give it 2, and then the size is a 2-dimensional array. Let's run, and then I guess you can see the results. To visualize again, to visualize guys, let me copy the codes, and then let me paste it here, and then here guys, I'm gonna change here to what? To Pareto. Pareto. Let me change it to Pareto. Then what else? We are gonna change this. Let's add in another argument here, another parameter. Let's give it A. Then give it 2. Let's give it 2. I said what is A? A I said is the shape of the parameter. And then here guys, what I do, let me add in another parameter here. For example, let me remove what? Let me remove the KDE. How do we remove that KDE? So let me say KDE. We have this boolean false. Then we visualize. Let's run, and then as you can see now the outcome here. Let me zoom in. Should I zoom out? Should be zoom in so that you can see it properly. So guys, basically this is the Pareto, Pareto distribution. Now let's talk about the Zipf distribution. Now the zips are basically the zip distribution are used to sample data based on the zips law. And remember the zips law is basically states in a collection the nth common term is 1 over n times of the most common term. Like for example, the fifth most common word in English occurs nearly a fifth times often as the most common word. That's an example of Zipf's law. So this one has two parameters. The first parameter is a distribution parameter. Then the second parameter, that's the size of the shape. That's the size or the shape of the returned array. So guys, let me show you that example here, guys. Let me just copy. Let me just copy and then I use it here. Then I'm gonna change it to zips. To what? To zips. But then now this A here, you can see this A here. This one represents now the distribution parameter. Distribution parameter, not this one defines what the distribution parameter, not the array parameter here. Then the size, does the shape of the returned array. Then let's do it. Let's visualize. Then I guess basically you can see the outcomes here. How do we visualize? To visualize, just we do the same thing. Let's copy the codes, and then now we are gonna modify this fifth line of code here. This fourth line of code, we're gonna change it to zips. Zip like this, zip, and then here we're gonna change here to let it be the way it is. However, we're gonna add in what? We're gonna add in another parameter here called what? So I think what I do here, guys, first of all, let me assign this one. Guys, I don't want to confuse what I do. What I do, guys, let me just delete this line of code. Then let me just retype it again so that you can understand. First of all, let me create a variable for this one. Then assign it to random dot what dot zip, and then I'm gonna add in this parameter a. Define the shape of the distribution to. Let me give it 2. Then the size, it can be what? Let me give it 1000. Let me give it let me give it 1000. And then here, guys, what do I do? Let me say let me here in this new line of code, let me say SNS. Remember this the alias for a seaborn, and then here you do what? Let me say list plot. List plot, and then I'm gonna assign it here to x. Then let me say what? Let me say x to be less than. Let's give it less than 10, right? And then here let's remove what? KDE. Let's assign it to a false value. Let's assign it to a false value. Then let's try to visualize and see its appearance. So guys, basically you can see the outcome here. So guys, it's quite interesting. So this is all about what the Zeus distribution. So guys, the next thing that I want us to talk about here is the universal function, the Numpy funcs. So guys, the other thing that I want us to talk about here is the universal functions, or Numpy funcs, and these funcs stand for universal functions. They are the Numpy functions that operate on the ndarray objects. But first of all, why should we use the universal function, the funcs? Basically, funcs are used to implement vectorization in Numpy, which is way faster than iterating over elements. So they also provide a broadcasting and additional method to reduce, accumulate, and so forth, that are very, very helpful for computation. Now, funcs also take additional arguments like a where. Now, this one is a Boolean array or a condition defining where the operation should take place. And then also you have the dtype. And this one defines the return type of the element. And then a out, that's the output array where the return value should be, copied. So I talked about vectorization. I said that the functions are used to implement vectorization in NumPy, which is the way faster to iterate over elements. But first of all, what is vectorization? Now, converting iterative statement into a vector-based operation is what we call the vectorization. It is faster as a common CPU are optimized for such operations. So, guys, for example, let me show you how we can add elements, perhaps elements of the two list together. Basically, one way of doing it is to iterate over both the list and the sum of each elements. Let me show you first of all without the universal function how it looks like. Let me just create the normal Python list. Let me use a variable like a x. Though remember, guys, I warn you that it's not a good practice to use these are short words, short abbreviations. It will be good to use some descriptive names to define your variable. However, let me just say perhaps 1, 2, 3, 4, and then also let me create another one. Let me call it y. Then here, let me assign it to 4, 5, 6, 7. Then for y, let me give it an empty list. Z, not really y, it should be z, right? Let me give it an empty list. And then here, to iterate, the normal iteration, let me say for, without actually, without the, you know, without the universal function. Basically, Python has a built-in method called a zip, which can help us to do it, can help us to iterate, you know. So first of all, for I, you say for I, j, then you say zip, in zip, then you assign the values where you want to, to iterate, or to, you know, to, yeah, basically to do the summation, actually to iterate in that, do the summation there. So for example, I'm going to use the x in the y, x and y, and then colon, you close, and then now let's say z now, this variable here we want to append. So let's say append, then now we're gonna say we're gonna append, but do the summation for I and the what, in the j, I and the j, like this. Then now what we do, let's print out, let's remove first of all the indentation here. Just say printing what, z. So let's try to run and see if it will work. And then again, basically you can see we have, combined. For example, 1 plus 4, that is 5, 2 plus 5, that is 7, 3 plus 6, that is 9, 4 plus 7, that is, 11. So basically this is how you can iterate over elements and do the summation of the elements and get the output. So basically this is without the, the NumPy universal functions. So NumPy universal function, uh, it has method for this called add, which will produce the same results. Let me show you with the, with the NumPy universal function. So you can use the add function. So first of all, let me say x, then assign it to, let me use the same values, guys, so that you may see that it is the same. Let me paste it here, and then z, I can assign it to the NumPy. First of all, guys, I forgot I should have imported. Remember, before working with any module, you must import the module itself. And then here, let me say what? Let me say import. Sorry, should be import NumPy is what? NP and here we are going to use the add. And then in this add function, let me say we are adding x and y, and then let's print out z. So let's say print z. Then let's run. So guys, you can see, you can realize that this way is too much faster, than the other one. So basically, this is how you can work with, the universal function. Now, let me show you how you can create your own, universal function. To create your own universal function, you have to define a function like you do with a normal function in Python. Then you add it to your own NumPy universal library with the, from pyfunc method. And then now the from func method takes the following arguments. We have the first argument, which is function, the same name as the function. And then I input, this is the number of the output arguments array. And then we have the outputs. These are the number of the output arrays. So let me show you guys this example right away so that you may understand what I'm saying. I want to create our own, universal function for addition. Now, first of all, you import what? You import the library, the code library, which is a NumPy, is np-alias, and then we can define our function using the div keyword. Then let me call it perhaps my addition function. Then this x and y, and then you do what you remember always to do, to close. Then let's say return return, we're gonna return x plus y, x plus y. And then now here, let's say my add now, let's call that function my add. Let's create a variable for that my add. Then let me assign it to the numpy np, and then np, and then what? And then use this method here to use your own universal function. You have to use this method also from pi, from pi function, from pi func, like this. Then we're gonna do this. Let's pass in add. Should be my add, right? My add. Then we add not perhaps, let's say specify 2, then also perhaps 1. And then to the print function, what I do, let me say print. I'm gonna print my add. Remember, once you define a function, you must always call it for it to work. Then here I'm gonna pass in some list here, some list of 1, 2, 3, 4. Let me add in what? Let me add in another perhaps. Let me call it. Let me have some values like let me say 5, 6, should be 6, 7, 8, like this. And then what I do, let me run. And then guys, you can see it has done the summation there. And we have gotten the result. So you can create your own universal function. Now let's check if a function is a universal function. So guys, basically to check the type of the function, if it's a universal function or not. Remember guys, basically a universal function will return something like a numpy.ofunc. It will be class numpy.ofunc if it's a universal function. So let me first of all check it out. I know we have just created our own universal function, but how do we check it? So first of all, let me show you guys first of all how we can check the universal function. First of all, you must import the code library, the module numpy is a np alias np, and then the print function. For example, we want to check a function, like let's check this function, concatenation function type, and then here let's say np should be np dot concatenate, np dot concatenate, and then what I do when I run, it should return something like this one. You can see this one, it has just returned a function. If the function is not recognized at all, it will return an error. Like for example, let me say if it was something like let me say nametake, we all know that it's not a function, so it must return an error. So you can see it returns what? It returns an error. A module numpy has no attribute called a nametake. So these are basically, it won't return and the error. So to test if the function is a universal function basically in an if statement, we have to use the numpy.ofunc value, or basically numpy.ofunc if you have to use np, it's an alias. So let me show you that, guys. So here first of all, let's import, should be import numpy is what? np alias. And then let's use now the if statement this time round, then a type, and then a type, and then here we're gonna do this. Let's say np dot add, and then here Let's equate it to np dot ofunc like this, and then close with a colon, then let's say print, let's say print, and then let me say add is ofunc, add is ofunc, then let me say otherwise, let me say else, let me say else, then should be else, right? Else print the string add is not, ofunc. So let me try to run and see if it will work, right? And then you can see add is a universal function. So guys, basically this is how you can do this, how you can use an if statement to check if a function is an ofunc or not. Now let's talk about the simple arithmetic here, guys. Let's talk about some of the basics arithmetic in universal function. So you could use arithmetic operators like a plus, minus, multiply, division directly between numpy arrays. But at this section, guys, I want us to discuss an extension of the same, where we have a function that can take the any array like objects, list that can be list, tuples, and so forth, and perform arithmetic, conditionally. Arithmetic conditionally means that we can define condition where the arithmetic operation should happen. Basically, all of the discussed arithmetic function takes the where parameter in which we can specify that condition. Like let's begin guys with the addition. With the addition guys, we have to it has the add function which sums the content of the two array and returns the results in a new array. Like guys, let me first of all let me import numpy is np alias, and then here let me create array 1, then let me assign it to a numpy array np dot array, and then in this array list I'm gonna pass in some values, like for example let me say 10, 11, 12, 13, and then perhaps 14 to 15. So this is array 1, then array 2, let me assign it to the numpy array np.array, and then here I can do it, I can pass in 20, 21, 22, 23, 24, 25, and then here the new array, let's call it let me just call it array, right? Let me just call it array, then let me pass in the numpy np.add now, and then here we're gonna pass in array 1, sorry, it should be array 1 array 1 and also array 2, then what we do, let's print out the new array. You'll find out that it has done the summation of the two. So let me say print, and then array, you print an array, then what we do, let's run, then again basically you can see it has done the summation 10 plus 20, that is 30, 11 plus 21, that is 32, and so forth. And so basically this is the summation of these two arrays. Now for subtraction, you just do what, you just do subtract. Instead of add, you say sub. Is it subtract or subtract? Subtract, right? Then again you can see it returns, the negative here. Basically the negative stars, because yeah, so it has basically 10 minus 20 that is negative 10, 11 minus 21 that is negative 10, and so forth. Now for multiplication, guys, we just do multiply instead of subtract. Just say multiply like this, then it will do the multiplication. Now for division, it is divide. Divide like this, then it will do the division, So for power, it just power, you just change it to power, then it will do the power and so forth. And then also remainder, you just add in there mod, it will do the remainder. Like let me show you that. It will do that. So guys, basically what I do, let me talk about the remainder. Guys, basically remember both the mod, this one that we have just used here, and the remainder function returns the remainder of the value in the first array corresponding to the values in the second array, and that returns the results in a new array. Now this is with the mod. Now let's try with the remainder itself. Like this, and then let's run. And then I guess you can see get the same results. Now for quotient, you can do the same. Basically for quotient, we have the function called diff mode, a function which returns both the quotient and the mode. So basically this one will do it. This one returns value. Basically this one returns value. The return value basically here is two arrays. The first array contains the quotient, and the second array contains the mode. Like let's do that. This one will do the division and the remainder. So like let's say div mode. It will do first of all the division. We will get the result for the division in the first array, and then for mode in the second thing. You can see 20 goes to 10 0 times, and then you can see the remainder there. So we have many other stuff you can try. You can go to the website and find other examples. So guys, let's talk about the rounding decimals. And basically we have 5 ways of rounding off decimals in Numpy. You have the truncation, you have the fix, we have the rounding, you have the floor, you have the sale. I'll show you some. The rest you will find it at the website. Let's begin with the truncation. And the truncation is to truncation. Basically, this one remove the decimals and return the float. Basically, the floating number closest to 0. Now we use the trunc and the fix function in this case. So let's guys truncate elements of this array. First of all, let's import numpy as what np alias, and then let's get some array. Let me assign it to the numpy, but here we're using trunc. Trunc like this, and then here we are passing what? We are passing these values. Perhaps let me create here -3 point something like a 166 and so forth. Then at the other one, perhaps let me say 3 point for example 667 like this. So I want us to truncate the element of this array. Remember, truncation I said is to remove the decimals and return the float number closer to 0. Now here at the print function, let me say print that array and see, let's see if it will work. And then I guess basically you can see it has done what it has, removed the decimals, and it has done what it has, returned the float number closest to 0. So We also have the fix. Let's try with the fix function. Instead of trunk, we're going to use fix. And then let's run. And then again, you can see we still get the same results. Now, let me talk about now the rounding. Now, the round functioning, basically the other part of removing decimal or basically working with the decimals is the rounding. Now, in the rounding, you have the round function, which increments preceding digit or decimal by 1 if it is greater than or -5, else it will do nothing. Like for example, let me show you guys an example here. For example, in this case, like guys, for example, in this case, for example, here, let me just add in another value. Like let me just say 2. Let me say 2 like this. Let me first of all remove the negative. Now, guys, basically in this case, it will round off what? It will round off this value to 1 decimal point. In this case, it will round off to to the 1 decimal places. Actually, this second parameter defines the number of decimal places to be found there. Like for example, if I run, first of all, I should have changed here to around dot around, dot around. And then now what I do, let me run. Then again, as you can see, it does that. So it returns to 2 decimal places. It has rounded off to 2 decimal places. Also, guys, we have the flow. Perhaps let me show you that. Let me begin with the negative parts. Then here, let me add in a positive. And 3.67. You can try with any other. Let's run. Not really, this one is around. However, I want to try with a flow. np dot flow like this. Then let's run. And then I guess you can see it does the rounding off here. So now the flow function rounds off a decimal to the nearest lower integer, to the nearest lower integer. Like in this case, guys, you can see it has returned to -4. Remember, -4 is less than -3. -3 is greater than a -4. Now for cell, the cell function rounds off decimal to the nearest upper integer. Now for these are 3, it will be 4, right? If it's upper integer. So so here let me say cell. You can see previously this one rounded off to the lowest, to the lower integer, but now this one cell say like this, it will round off what? To the upper integer. So you can see it is 3, then this one is 4. So guys, I think you've understood that. Now let me talk about another thing here in the NumPy universal function, and that is logs. So NumPy provides function to perform a log at the base, perhaps base 2, and basically base 2 in E and 10. So we'll explore how we can take log for any base by creating a function, our custom function. Basically all the log function will place inf or basically negative inf or inf if the elements in the basically in the elements, if the log cannot be computed. Guys, I want us to begin, for example, with the base 2, log at base 2. Now, how do we use the log function to perform log at the base 2? So let me show you an example here, guys. To find the log at base 2 of all the elements in an array. Like, first of all, let's import numpy is np alias, and then let's create our array. I'm gonna assign it to np dot arrange. Let's arrange. All the spelling should be arrange, right? Like this, not double r. Then here, perhaps 1, then 10. 110. So guys, I want us to find the log at base 2 of all these elements in this array. Guys. So here I say print, and then I'm gonna print np dot log 2, basically log 2, and then here we're passing what? Our array object, which is array. And then guys, you can see there's an error here, right? Arrange is not defined. So what's the spelling of arrange that I should have used? NP. Oh, guys, basically here it should be dot, not really, not comma, should be dot. And then again, you can see it does. So you can see it as return what? It has find the log at base 2 of all these basically of these array elements, But then guys, remember that this arrange 1 to 10 function returns an array with the integers starting from 1 included to 10 included. No, basically to 10 not included. That's why we get these results. But let's try log at base 10. Log at base 10 we just change it to 10. Then let's run, and then again you can see the results here. Now for natural log or a base at e, we use the log the log without anything. For example, just say log like this, then this one will return a natural log or a log at base e. Then again you can see it returns the values. Now log for at any base. How do you define a log at any base? Numpy does not provide any function to take log at any base, so we can use the from py function along with the inbuilt function math.log with the two inputs parameter and the one put parameter. So guys, let me show you that, guys. Let me delete these tabs first of all, and then now we also have to do what we have to import the math module. So let me say from math, first of all, we are going to import the log, import log. All right, then let's get our variable. Let me call it np log. Then let me assign it to the numpy dot from py func like this. Func, like this. And then here we're gonna pass in the log first of all, and then 2 and 1 like this. Then here let's say print that variable np log, and then I pass in 100, and then now it is 15 like this. And then now what I do, let me run, and then okay, so basically you can see it has done what it has returned the the results are there. So that's how you can create your natural, or basically you can create your defined logarithms. Now let's talk about the summations, guys. Now basically what the difference is between summation and addition? Addition is done between two arguments, whereas summation happens over the number of elements, the n number of elements. So for example, where was that segment where we did the summation? Let me copy these codes because I'll modify a bit instead of retyping everything. Now here, guys, let's begin with the addition. Let's begin with add. Then let's run and see. You can see that's the summation here. It has returned what it has returned, basically in an array list. Now basically for some basically the sum is the values in this array 1 and array 2, the combination. then it will give us, just a single result, not in an array list like this. So let's change that, and then I'll do the sum. Let's run, and then guys, first of all, it has printed out an error. Only integer scalar array can be converted to a scalar index. So let's find out where the problem is. Sum np dot sum, and then oh guys, basically I should have used the brackets. I forgot to modify a bit. I should have done this. And then what I do, let me run. And then I guess you can see the summation of these steps here is 210. So that's how you can do that. And now summation over axis, you can specify the axis that you want to do the summation. For example, in that case, you have to add in another parameter for axis. That is axis. You specify the axis that you want to do the summation axis, and then I specify example 1, let's run, and then guys, basically you can see it has done the summation of this one, then at the summation of this other one, So that's how you can do the summation. Now for cumulative summation, gives you, let me delete this one. Perhaps you might understand this stuff. For cumulative summation gives you just you pass in the array here. Should be array 1, right? Array 1, and then here I can pass in out the cumulative summation or a cum sum like this. And then when you run, so guys, basically you can see this one does the cumulative summation. You can see the first one is, remember the previous one is assumed to be 0, that was 0 plus 10, it is 10. But now this one is 10 plus 11, that's why we got 21. Then 21 plus 11, 12, we get the 33. Then 33 plus 13, we get 46, and so forth. So that's how you can do the cumulative summation. Now, let's talk about the number of products. Now, to find the products of the elements in an array, we use the prod function. Like guys, here, let me show you that. Let me just add in that. Let me just add in this function called prod. And then let's run. And then guys, you can see it does done the products. So what it does, it picks 10 times 11 times 12 times 13 times 14 times 15, and that's why we get that 6, this value, this many values here. So you can do the same for two arrays. Like let me copy. Now in this case, guys, you have to do it. You'll have to pass in a list. Sorry, you should pass here a list for it to work. For example, say array 1, and then array 2. Array 2, of course, here should have changed it to array 2. And then when you run, let's run, it will do what? When you run, guys, basically this one finds the product of the element of these, two arrays here. So yeah, but then now let's talk about the products over the axis. Now for products over axis, guys, you have to specify the axis, perhaps 1, and then at this one we return the product of each array. Like if you want to return that, you have to add in the axis parameter. You are setting it to 1. If you want to obtain the results for each array, then it will get the results for each array, and you can see both that 6 because they're the same, right? And so that's how you can do that. And then for cumulative products, we just use the cum product like this, and then it will do what? For axis, if you specify the axis, it will do for each, it will do for each. So it is 10, 10 times 0, or actually 10 times 1, it is 10, 10 times 11 on 10, and so forth. So that's how you can do that. So guys, the other thing is the difference. Now basically a discrete difference means subtracting two successive elements. For example, I'm going to show you an example, guys, in a few. However, to find a discrete difference, we use the diff function. So let me show you how you can compute discrete difference of an array. Like here, let me just remove this first array, second array. Then here, perhaps let me just delete these stuffs. Then I pass in only array one. Only array one here. Basically array one. And then here I'm gonna change it to diff. I say that we use the diff function here to obtain the discrete difference. And then what I do is let me run. And then I guess basically you can see the discrete difference here is 1. 11 minus 10, that is 1. 12 minus 11, that's 1. That's why we got that result. So we can also perform this operation by repeating. Guys, basically you can do the operation by doing the repetition of the given parameter, the number of the given parameter. Like for example, let's do this. Let's perhaps in that case, guys, you have to add in another parameter called, first of all, n. Then you assign into the number of repetition that you want. And then what we do, let's run. And then again, you can see it has 0. So let me try to explain this one. So the first thing, it subtracted 11 minus 10, we got 1, 1, 1. Then I did the same operation. So 1 minus 1, we got 0, 0, 0. So it does the operation repeatedly. After it has obtained the results, it also do the subtraction again. Now let me talk about LCM, that is lowest common multiple. How do we find the LCM? So basically the lowest common multiple is the smallest number that is common multiple for basically of the two numbers. I'm gonna show you. First of all, let me do this. Let me just delete these stuffs, and then here perhaps let me call it number one. Let me assign it to something like 6, and then the second number, let me say num2. Let me assign it to something like 9. So for LCM, we use this function. Let me just say x. Let me assign it to np dot LCM. And then here we're gonna pass in num1 and num2. And then what I do here, instead of array, we are gonna pass in x now. And then I guess you can see the LCM of both 6 and 9 is 18. Is 18. So this is the lowest number that is common in multiple there, and basically these are two values here. So how do you find the LCM in an array? So guys, basically to find the lowest common multiple of all values in an array, we can use the reduce method. And basically the reduce method will use the function. We'll use the universal function. In this case, that is LCM function on each element, and reduce the array element by one dimension. So let me do this. Let me just, let me create an array. Let me call it array. And then here I'm going to assign it to the numpy array np array. And then here I'm going to pass in a list. Perhaps let me call it the LCM for 3. I want to obtain the LCM for 3 is 6 and 9. I know that is 8, it will be 18, like, but now here we're going to add in this other function called reduce. LCM.reduce. And then now what it does, here guys, instead we are going to pass in the array. And then you can see it still give you the result 18. Perhaps let me try to add in several, like let me also add in let me add in what? Let me add in 5 like this. Then I return. Then the you can see the value which is common in everything here, it is 90. That's the least common multiple there. And then let me talk about the other thing. Let me talk about that should be GCD. That's the greatest common denominator. So how do we find the GCD, or the greatest common denominator? First of all, GCD, that is greatest common denominator, it is also called the highest common factor. And this is the biggest number that is common factor on both of the numbers. So let me show you that. In anything, before using any module, you have to import it. I said several times, import numpy is np alias. Then let me create number 1. Let me assign it to 6. It should be what? It should be 6. And then num2, that should be 9. Then here for x, let me assign it to np.gcd. Then I pass in num1 and num2 like this. Then we are printing out what? Print and then x, right? Then let's run. And then guys, you can see this is the greatest common factor here, the highest common factor, or the greatest common denominator. Actually, the highest value that is common in both 6 and 9, that is 3. The one that is kind of divisible in both of them, actually the highest number that can get into them without the remainder, that is 3. And then now finding, how do we find the GCD in an array, in the array, like for example, let me just use this other one, because here instead of LCM we just change here to GCD, right? GCD for the sake of time. And then it returns what? 1. Only 1 is the highest number that can get into everything here without the remainder. If it were just 9, it will be 3, right? Yeah, you can see here it is 3. So let me talk about the other thing is, let me talk about the trigonometric function. Numpy provides the universal function for sine, cosine, and the tangents that takes values in radian and produce the corresponding sine, cosine, and tangent values. Let me show you guys how we can find the sine of the value of pi, perhaps pi over 2. So let me just use a new cell for you to understand. Let me say import first of all. Numpy is a np alias, and then here I'm gonna create x and then assign it to np dot sine. Let's begin with the sine, and then I want to find the sine of the pi over 2. np dot pi over 2. Then let's do it. Let's print the x. So guys, basically this one will find the sign, actually the sign of this value of pi over 2, that is 1. So basically, but how can we find the sign values for all the values in the array? Basically, for example, if you have an array, let's create an array here. Let me create an array, call it array, then assign it to np array. Then in this array list, I'm gonna pass in pass np. Let me use this one. Let me just copy. Let me add in several here. Not really. Let me copy. And then I here perhaps let me change the values here to be 3. And then I here perhaps 4. And then I here let me change here to 5. And then here I'm gonna do as let me just pass in the array itself so that it may do find the sign of this all these array. It should be array, right? Array like this. Then let's try to run. And then again, you can see it has found the basically the sign of these arrays in these array elements here. Now, how can we convert degrees into radians? So guys, basically by default all of the trigonometric function takes radians as parameter, but you can convert radians to degree and vice versa. And so basically in Numpy. So for example, remember radians are values. Basically radians values are pi over that is 180. The degree value. Let me show you that is for example, let me say import. First of all, let me use just a new line of code. Let me say import numpy is np alias, and then let me create our array. And then let me add in some degrees here. Np dot array. Then pass in some degrees, perhaps 90, 180 to 70, to 70, perhaps 360. Any other angle. And then what I do here, let me say x, then assign it to np dot. Now I want to convert from degree to radian, so degree to radian, then targeting what the array, basically array. And then what I do, let me run and see if it will work. Degree into basically not really. Oh yeah, sure guys, I should have added in the print function now. Let me say print should be x, right? Then let me run. And then guys, you can see now we have converted these are degrees into radian. You can see the radian of the 100 of 90 is 1.5.7079633 and so forth. So guys, that's how you can do that. Now for radian to degrees, that is the vice versa. Let me use this other one. We all know that this one is a radian. Now we want to convert it into degrees. How do we convert it? So it will be a radian. This one was the other one was degree to radian. Now this one will be radian to degree, right? To deg, like this. And then what we do guys, let me run, and then you can see now it has returned the values. You can see the first radian pi over 2 is 90, the second one is 60, 45 and so forth degrees. Basically the values are in degrees. But how do we find the angles? Finding angles from values of sine, cosine, and tangents, guys, just the inverse of the arc sine, arc cosine, and arc tangent. If you want to find the angles, so basically, NumPy provides a universal function for arc sine, arc cosine, and arc tangents that produce radians for corresponding sine, cosine, and tangent value. Guys, let me just show you that. let me say import numpy. Numpy is a np alias np. Then I have, for example, x, the variable np dot arcsign, arcsign of perhaps 1.0. Let's find out. Then let's say print x. Then let me run. Oh, basically, guys, it shouldn't be arc. I added the h, should be arc sign like this. And then I guess again you get the results here. So you can also do the same for the arrays. I want to give you as an assignment. You can do the for an array, because I've just showed you several examples of the same. You can try yourself with an array. However, let me talk about the hyperbolic function. Now, basically, NumPy provides the universal function for sin h, cos h, and the tangent, tan h, that takes values in radian and produce the corresponding sin h, cos h, tan h values, and so forth. Let me show you that, guys. Do I have something somewhere? What I do is let me just copy this value, or let me just modify it. So, for example, for sine, if I want to find the sin h, it should be sin h, for example, of np dot pi over 2. Let's find the results. Let me run. Then guys, you can see it is 2.3000. You can do the same with the arrays, and to find the angles, guys, you just do the arc psi h. Let me show you that. For example, if I want to find the angle, so for example, it will be you'll do to get the opposite. Actually, to find the angle, to be arc sin h. Then you'll get the result. It does the opposite. Now, let me talk about the other thing. You can try with the arrays, but let me talk about the NumPy set operations. Let me talk about the NumPy set operation. Guys, as we wind down. Now, what is a set? Basically, a set in mathematics is a collection of unique elements. Now, sets are used for operation involving a frequent intersection, union, and different operations. So, let me show you guys how you can create sets in NumPy. Now, we can use the NumPy unique method to find the unique elements from the array. We can create, for example, we can create a set, but remember that the set array should be only one-dimensional array. First of all, let me show you how we can convert an array repeatedly, basically with the repeated elements to a set. Let me show you that. Import a NumPy is np alias, and then here let's create our array object in the variable. It should be array. Then let me assign it to np.array, and then here I'm gonna do some repetition of other values so that it can be unique. So let me say, for example, 1 1 1 2, sorry, comma 2 and 3 4, then perhaps 5 5 6 7, and then let's try to find the unique. Then let's say print up, not really before print, or let the print be there. And then here let me also add in another variable x. Then let me assign it to np dot unique np.unique, then we're gonna pass in array. We're gonna pass in the array, and then here the print function should be x now. Then let me run, and then basically you can see now it has removed the unique. It has obtained it has converted this array basically with the repeated, removing the repeated elements so that it can be somehow better. That's why you can see now it's 1 2 3 4 5 and so forth. How can we find the union? So guys, basically to find the unique values of two arrays, we use the union ID method. So this is let's call it this one to be array 1. Let me create another one for array 2. Perhaps let me change here the values. Let me just use simple ones like 1 2 3 4, and then this other one let it have also 3 4 5 6. Here should be 1, here should be 2, and then here we're changing to union ID. Union basically not union ID should be union one dimension, or a union one dimension. I think you guys understand, not ID. Then here should be array 1, and then array 2, and then let's print out x and see the results. You can see now we have obtained what these results here. So it has combined, but it has removed the repeated here. Basically it has combined array 1 and array 2, but we saw that 3 is here, and then also another 3 4 is here. So it has filtered out, and then it has done that without those repetition of those values here. Now for intersection, how do we find the intersection? Also guys, for intersection guys, you have to use the intersect 1D ID 1D, so it will be intersect intersect 1D, and then but in that case you have to add in another parameter called assume unique. Unique, we are going to give it true, and we are giving it true, and then let's print out and see the intersection, and then you can see it is 3 and 4. That is true. You can see 3 and 4, those are the intersection. So guys, there's something here that you need to understand. Basically, this is a statement. Intersect 1D makes basically method takes an optional argument, assume underscore unique, which if set to true can speed up computation. If basically it should always be set to true when dealing with set to speed up the computation. So basically is how do we find the difference? For example, if you want to find the difference of the set 1 and the set 2. So for difference, we just change here to let me assume this one is set, or let me just change here to set 1. Set 1. Let me call it set 2. But remember, variable name doesn't matter. However, here I want to let me change here to set to let me change here to set set diff set diff 1D, set diff 1D, then here should be now set, also here set, and then this optional argument here you should also add in here so that you may have proper computation. And then here you can see there's an error. Oh guys, basically I should have changed here to 2, right? Then now when I run, we'll get the result that is 1, 2. So basically this is the difference. This is how you can obtain the difference. Now, but you need to know that the set underscore a leaf method, just like in the other one, takes optional argument assume underscore unique, which is set to true to speed up the computation. So guys, basically this is how you can do the difference. You can also do the symmetric difference, but guys, or let me just show you that. Let me just show you because we are finishing. Let's finish in style. So let me say let's talk about this asymmetric difference. Now basically guys, is to find only the values that are not present basically in both sets. You have to use the set x for basically the set solved basically sets or 1D method for that case. Like guys, basically in this case here you have to use this method here called a set sets or 1D. Then you pass in your set, and then when you run, you'll get the values for which is not available in either the ones which are not available here. You can see the values which are not available in set 1 and 2, the ones which are not available. Basically it has excluded the values which are available here. You can see 3 and 4 is available in set 1, and also it's available in set 2. That's why it has excluded, and it has used 1, 2, 5, 6. You can see 1, 2, 5, 6. So guys, basically that's how you can do the the solve. You can do the symmetric difference of these set 1 and set 2. So guys, congratulations for finishing Numpy full course. I really appreciate you so much for your commitment and your time. I really appreciate you so much. And guys, I always like these videos, share it to your friends so that they too may gain some skills. And I guess I assure you that if you have understood every concept in this course, now your data science career will have a very big impact, because as you can see, this is very fundamental for data scientists, and also machine learning engineers. So guys, I really appreciate you so much, and let's meet in the next course. I think the next course I'll talk about the NumPy, SciPy, or Pandas, something like that. However, at this juncture, guys, I want to appreciate you, and guys, I'll see you next time. Thank you.